68.
Can you see my
Ayan.
slide now?
Yes, Kuya JP.
Okay, we can start na.
Okay. Good morning everyone. Maraming salamat po ulit sa pagsama sa amin ngayong Saturday. And today, we will be having a special introduction class for for alkenes and the reaction mechanisms of alkenes. So, nagbabalik po ang ating resident lecturer, si Dr. Dindi Voils from Louisiana State University, together with our founder and CEO, Dr. Jeffrey Bunquin. Next slide, please. Ayan, so mamaya po, we will be posting a Google form sa aming Zoom and YouTube chat box, and you can fill it out, and you will have a chance to win an organic chemistry book by John McMurray, 9th edition, and also organic chemistry model kit. So dalawa pong organic chemistry model kit and uh, isang organic chemistry book by John McMurray. So antabayanan nyo lang po yung pag-post namin mamaya ng Google Forms sa aming comment box sa Zoom and YouTube. Next slide po. So before we start our webinar, reminder lang po to turn off your video and mute your mic unless you want to pose a question at the end of the webinar. You can of course ask your questions live via raise your hand button, or type in your questions sa ating YouTube and Zoom comment box. And please don't record the session because all of the sessions will be uploaded on the official YouTube channel of Fieldside Hub. Next slide po. And we will also be issuing you a certificate of participation after the session. We will post a Google form link to issue a certificate of participation for this session in the Zoom chat box and in the YouTube live comments. And also, if you will miss the Google form link sa YouTube chat box and Zoom chat box, ilalagay din po namin to sa video description sa YouTube na i-upload namin of the whole session after this webinar. So for you to get your certificate of participation, you should be an official subscriber of Fieldside Hub official YouTube channel. That's at Fieldside Hub. And also, please do like our Facebook page. That's Filipino Science Hub. And you can always visit our website to get the link for the Google form link for the certificate of participation sa philscihub.com. Next slide po.
Okay.
Ayan. So to introduce our platform, I turn the virtual floor to Kuya JP. Kuya JP.
All right. So magandang umaga po sa lahat ng participants natin here on Zoom and also from YouTube. So I think mapupuno na yung natin yung Zoom natin. So we strongly suggest everyone to just follow the discussion on YouTube Live sa Facebook sa YouTube channel po namin. Okay? So again, maraming salamat po for joining us and welcome po sa mga ngayon lang po nakasama namin sa webinar namin, and for those who are not very familiar with our group, the Filipino Science Hub, I just have a few introductory slides to show, right? So the Filipino Science Hub is our group tries to promote the STEM culture, STEM education among teachers and students in the Philippines. It was founded by our CEO, Dr. Jeffrey Bunquin, back in 2012, but it was only last year that we went full on with our webinars and mga tutorials like the one we have today to augment yung mga training materials po ng mga teachers natin, and also to promote the STEM culture as a whole. Okay, so we are a 6-man team headed by our founder, Dr. Jeffrey Bunquin, and we also have Dr. Dindi Yu Voils, Marty Mateo, myself, Professor May John Aguila, and Janice Averilla from the US. So right now, ang Fieldside Hub, ang vision po namin is to create a technology and innovation-driven Philippines, and we would like to promote that by having two thrusts. We have the Fieldside Hub Ed, or shorthand for Fieldside Hub Education, and we have Fieldside Hub Research University for practical STEM applications. So sa Fieldside Hub Ed po, we would like to empower STEM educators by providing learning materials like webinars and tutorials like today, para po matulungan yung mga teachers natin on how to instruct certain STEM topics. And also we provide modules on our website that teachers and the students can learn from. And yung pong mga modules namin ay MELT-based. So I will discuss that later. So we have this division, Fieldside Hub Ed, right now, and to put into practice whatever we put out on Fieldside Hub Ed, we have the Fieldside Hub Research University, which is the research arm of Filipino Science Hub. And here, we try to bring STEM practitioners closer to the educational sector. So mapapansin nyo po, we are trying to invite and bring in scientists and different people from different STEM areas to provide lectures para po magkaroon ng figure or face yung mga uh, STEM topics so that we become more familiar, and hopefully yung mga students po natin will be encouraged to pursue careers in different STEM areas at mahanap po nila yung niche nila. And all of this, all of our vision, um, we try to create a new generation of Filipino STEM enthusiasts para po maka-keep up tayo sa mga neighboring countries natin in terms of research and in terms of the number of scientists. Okay, so it was already 12 months since it's already a year after our first webinar, and well, 1 year na po ang pandemic, and since then we have launched more than 30 web events, and that includes teaching webinars, career guidance, web lectures, research webinars, and other STEM related topics. And we have to update our numbers, but well, we already had more than 71 hours of expertise shared, and more than 15,000 live participants, unique live participants per event. And that would translate to more than 40,000 training hours. And we would just like to focus here on this slide on the Fieldside Hub Ed program. And we try to empower our STEM educators, our teachers, as our academic frontliners. And right now we have 30,000 strong Fieldside Hub members on Facebook, and we just thought that we have this potential to influence 30,000 educators, and if we would translate this into actual numbers, if we try to multiply the number of teachers, let's say on a 30-year career, each one would have 30 students. So that would translate into 27 million students impacted, and that's already a significant number in order to create a new culture of STEM. Okay. So in Fieldside Hub Ed, we try to bring in like the best of the best in terms of teaching and pedagogy. So recently we had educators from the US providing webinars on online teaching, strategies for online teaching and assessment. And ayan po, you can readily check them out on our YouTube page, on our YouTube channel, and also our website. And we have webinars. Now we have modules, which includes teaching guide, class activities, and even problem sets. And these are curated and prepared by our team from UP Los Baños, IMG Aguila, Ivory Tui, and Mark Cortez, who put up modules in video type. So may voiceover po yan, and lahat po yan ay yung collection po ng modules namin are available on our website for free. You can download it, and ayun, para maging guide po natin sa pagtuturo, because these are guided by the DepEd MELC's minimum learning, what was the minimum learning competencies from DepEd. Ayan. So recently in Fieldside Hub Ed, we have launched this Fuse Fieldside Hub STEM teaching webinar series. in partnership with the Foundation for the Upgrading of the Standard of Education, or FUSE, which is a member of the Lushutan Group of Companies, in order to and our objective is to elevate the quality of STEM teaching in the Philippines. So open po ito for teachers, all of our teachers in the Philippines or even abroad. And here we try to provide pedagogical training courses and also innovative STEM teaching courses. So ito po yung isang bahagi nung program na to, yung webinar series on pedagogy and innovative STEM teaching. So yung pedagogical training courses provided by FUSE, and also one of the premier universities in the Philippines in education. So inintay lang po namin yung MOA para po mapangalanan natin sila, but they are very formidable institution in terms of education. And doon naman po sa innovative STEM teaching, ito man po ang ipoprovide namin sa Filipino Science Hub. And we will invite some other scientists to bring to the table their expertise in terms of innovation and practical STEM topics. Okay, so recently we had our first webinar on this teaching webinar series last May 22, and we will roll out 8 webinars from here on to August. So ayan po yung mga topics. So you can just watch out for our announcement for these webinars kasi hindi pa po definite yung ibang dates. So ayun po. And we also there's also possibility for CPD units to be issued for these webinars. So right now we're just preparing the requirements for CPD units, and ayun po, pag nakompleto nyo po itong mga webinars na to, there's a possibility for CPD units to be issued. Kaya dun po sa mga magpa-participate, keep hold of your certificates of participation para po may issuehan kayo ng appropriate units of CPD. Okay? So, there's the webinar series, and yung pong STEM teaching program na to ay meron din pong pilot run for workshop. And ayun po, separate CPD units po siya dun sa webinar series. Kasi dito po we aim for our participants to come up with a module, STEM related module, applying all of the topics discussed in the webinar series, to come up with a STEM module para po ma-apply yung mga pedagogical and innovative STEM teaching skills. Ayan, so they would experience mentorship from seasoned educators and scientists, and also foster collaboration among their fellow educators. Ayan. Tapos yung mga makikreate po nila na modules will be shared on a national platform. So, ayan, ito po yung stage 2 nung STEM teaching program. And moving forward to Fieldside Research University. So ito po yung turf ko. My name po is JP Onya, and I'm heading the Fieldside Research University division. And Research U is a webinar series focusing on different aspects of scientific research. And here we try to bring in the best practices and some of our own research experiences in terms of carrying out a research project. And Fieldside Research University is also composed of 8 mandatory courses. So we are on to our 7th topic. So matatapos na po namin yung campaign na ito. So in fact, next week we have the seventh um, course or topic for Research University, which is thesis writing. And ayun po, parang nag-devise po kami ng Google Classroom for this program, and nandun po lahat ng courses doon sa Google Classroom. And if you search on YouTube, yun din pong lahat ng recorded webinars for this program. So i-send na lang po namin yung tawag dito, yung link for the Google Classroom with the email for your certificates of participation para makahabol po kayo kung gusto niyo pa dun sa Research University, because for all those who will complete the 8 mandatory courses, we will issue a completion certificate para po dito sa program na ito. Okay? So, kung interested po kayo, you can check the info webinar on Fieldside Research University on our YouTube channel. So it was launched last January. Ayan. Okay. And Fieldside Hub is always present on our platforms. We have our main platform, which is the website at www.fieldsidehub.com. And we're also ever present on Facebook, on YouTube, where we have almost 10,000 subscribers already. And we're even present on TikTok. So dun po sa main handle namin, which is the website, it contains all of our webinars, tutorials, modules, virtual lab, and features. Okay? So, ayan. I hand over the screen now to Marty to introduce our speakers.
Thank you, Kuya JP. And excuse me. Exciting times for our followers and lahat po ng nagpa-participate dito sa mga webinars ng Fieldside Hub, especially sa mga teachers po natin because of the CPD units that will be offered on the STEM teaching webinar series that we will be launching in the future. So watch out lang po for some announcements regarding the specific dates, lalo na po dun sa pedagogical aspect ng aming mga STEM teaching webinar. So again, I welcome everyone to this webinar, the introduction to alkenes and reaction mechanisms. Next slide, Kuya JP. So our speaker will be Dr. Dindi Voils. She is a graduate of chemistry at the Institute of Chemistry in University of the Philippines, Los Baños, and got her PhD at University of Houston. And ang focus po ng kanyang research is detection of molecules and cells labeled with magnetic particles using an atomic magnetometer. Ayan. So si Prof. Dindi po ay assistant professor now sa Louisiana State University in Alexandria. And also, some of her experiences include quality assurance and technical management at the top paint and coating company operating in the global market. She is also a quality consultant for a biopolymer manufacturing company before. And she has a diverse experience in environmental industry, biotechnology, and food chemicals. Next slide po. And of course, our next speaker is our founder and CEO, Dr. Jeff Bunquin, graduated also in UPLB, BS Chemistry of 2006, magna cum laude, and he got his PhD degree at University of Alberta with, of course, multiple awards. And now meron na po siyang 14 years of research experience, both in academia and in the industry. Nakapag-publish po siya ng 15 international peer-reviewed publications and also around 20 plus inventions and patents na grant po sa kanya and also pending for application. So without further ado, I guess we will start with Dr. Dindi. Dr. Dindi, you may now take the floor.
Thank you, Marty, for your introduction. So before anything else, let me share my screen. Can you see my screen now?
Yes
Yep.
po.
Okay. Okay, so good morning po sa lahat. Welcome again to Filipino Science Hub. And my name is Dindi Yu Voils, and it's my joy to deliver another introductory web lecture to everyone. And so this web lecture, the first part of this web lecture would be about the chemistry of alkenes. And then the second half will be about reaction mechanisms. So very basic po itong i-cover natin. We will not go into much depth. So basically, this is just your launch pad to explore more about alkenes. And maybe in the future, we can also have another lecture on other types of hydrocarbons like alkynes and aromatic compounds. All right, so I'm very excited about this talk kasi magpapamigay tayo ng maraming premyo tonight. When I was in college, I couldn't afford a textbook. So if you happen to be the recipient of that textbook, make sure to make the most out of it. Don't let it collect dust. If you don't use it, give it away to someone who will benefit from it, because the book is like the Bible in organic chemistry. So I'm really excited for the person who will be receiving the textbook. Okay, so before we move on to the main topic, so let me just share with you this slide. And as you can see, we have many fruits here, different kinds of fruits. And what do these fruits have to do with alkenes? Well, did you know that the compound responsible for the ripening process of most of these fruits and even some vegetables is an alkene, and it's actually an ethylene. So ethylene is a colorless and odorless gas produced by these fruits so that they become ripe, okay? And in fact, there's a TikTok video shared by Dr. Jeff Bunquin some time ago explaining or showing some experiment in ripening bananas because of ethylene. So let me quickly share that with you. It's just a 1-minute video.
Nandito na naman ako nag-iisa. Napakapakla ng love life. Speaking of mapakla, nakakagat na ba kayo ng mapaklang banana? Hilaw. Hindi pa hinog. Alam niyo ba na isang organic compound na tinatawag na ethylene ang responsable sa pagkahinog ng saging? Ito ay isang gaseous chemical na unti-unting inilalabas sa mga prutas para sila ay mahinog. Narito ang isang simpleng eksperimento para makita ang epekto ng ethylene. Kumuha ng isang saging at ilagay sa isang closed container, halimbawa isang ziploc bag. Patigalin ng ilang oras, makikita ninyo mas mabilis magkulay brown ang saging, ibig sabihin mabilis ang pagkahinog. Sa loob ng isang closed container, hindi makalabas ang ethylene, tumataas ang concentration nito sa loob, mas madali itong kumapit sa saging at mas mabilis itong mahinog. Kaya kung nabo, kaya kaya't nakabili kayo ng hilaw na saging at gusto nyo na itong mahinog, ilagay muna sa supot. Learn Science with Filipino Science Hub on TikTok. Learn on TikTok.
Ayan. So thank you, Dr. Jeff, for that educational video. So kung baker kayo and you don't have a ripe banana, kasi di ba yun yung requirement sa banana bread, ayan, there's a tip there to make the ripening process faster. Ilagay lang sa supot. Ayan, and we have actually more videos similar to this on TikTok. So if you're on TikTok, make sure to check those videos out. All right, so another introductory slide is here. Is this slide right here showing a picture of these plastic products. And so these products are manufactured using polymers that were made with alkenes as a starting material. So I showed these two slides to you just to show that alkenes actually impact our daily lives in our household or even in different industries. So it's important that we understand the chemistry of alkenes, especially if you're aspiring to be a chemist, because imagine life without these products, and imagine life with not unripened fruit, diba? So alkenes are quite important in our day-to-day lives. So like I said, this lecture is very basic, very introductory. So in college, whenever you study alkenes, you are expected to have learned some prerequisite concepts. So if alkenes is new to you, we suggest that you learn or review the prerequisite concepts that are necessary to effectively understand the chemistry of alkenes. So una-una na dyan, alkane nomenclature, stereochemistry, valence bond theory, skeletal structures and Lewis structures, bond polarity, and intermolecular forces of attraction. So we will mention a little bit of these concepts in the lecture, but we will not be going in depth on each concept. And Filipino Science Hub has videos on alkene nomenclature and stereochemistry, as well as skeletal structures and Lewis structures. And the rest we could probably post in the future, but there are many resources out there for you to learn and review these concepts. Okay, so my talk is divided into 4 parts. So I will be talking about the nomenclature or the naming system of alkenes, properties of alkenes, what are the uses of alkenes, and then the synthesis and reactions involving alkenes. So let's first discuss nomenclature. So alkene, as we know, is a functional group, has a functional group or a double bond functional group on the structure. And the double bond could be on the one end of the chain, alkene chain. So that's called terminal alkene. And the double bond could be inside the chain. So it's called internal alkene. And then just like alkanes, alkenes can also have, or the double bonds can also be found in rings. So we call them cycloalkene. And then also you may hear the term olefin for alkene. So it's a synonymous to alkenes. And they are also called unsaturated hydrocarbons. Alkanes are called saturated hydrocarbons. So let me just go over the rules whenever we're naming alkenes. Just like whenever you're naming alkane, the first step is to identify the longest chain of carbon atoms that contains double bond. And then you name that longest chain as an alkane, depending on the number of carbons. You use the Greek prefix to denote the number of carbons, and then you convert the suffix from -ane to -ene, because it's alkene, not alkane. And then from there, you number the longest chain to give the carbon atoms of the double bond the smallest possible numbers. And then indicate the position of the double bond in the longest chain by using a prefix, which is just the smaller number of the 2 carbon atoms of the double bond. And you use a hyphen to connect the number to the name. Step 5 is to identify, name, and number any substituents as is done for alkanes. And then lastly, designate the configuration as cis, trans, or EZ if necessary. So for the cis trans designation, we use that whenever we have 2 non-hydrogen attachments to the alkenes. And EZ designation is actually the more generic way of assigning these non-hydrogen attachments. But we normally use it if there are 3 or 4 non-hydrogen different atoms attached to the alkene. So E is a letter representing the German word Entgegen. Maybe I'm butchering the pronunciation, but it means the higher priority groups are opposite one another relative to the double bond. And Z for Zusammen means the higher priority groups are on the same side relative to the double bond. So we will have example to make sense out of these roles. So let's start with a very simple one. And this is the skeletal structure of an alkene. And from our knowledge of alkane nomenclature and skeletal structure, we know that each stopping point corresponds to a carbon, right? And so for this structure, we have 3 carbons. So that means it's propane if it's an alkane, right? But since it has a double bond, then we are changing the suffix to -ene. So it becomes propene. Now here, if it's on the terminal chain, we don't really need to assign the double bond at carbon 1 as 1. It's automatically understood that the double bond is on the terminal side of the chain. So likewise, for this structure, we have how many carbons, how many stopping points? We have 1, 2, 3, 4, 5, 6. There are 6 carbons. And so therefore, if it's an alkane, then it's hexane. And again, we are converting the suffix -ane to -ene, so it becomes hexene. All right, so what if the double bond is internal? Okay, so again, similarly, we count the number of atoms, and that becomes our parent chain. So that's 1, 2, 3, 4, 5. Pentane becomes pentene because it's alkene. And then we assign the number on the carbon that is nearest to the one end of the chain, so that we get the lowest number. So in this case, we start counting from the right side, because this is the closest end from the double bond, right? It will give us the lowest number on the nomenclature. So this becomes 2. And we cannot count from this side because it will become 3, right? So we can name this as 2-pentene. Or it's also acceptable to write the number 2 in between the Greek prefix penta to -ene. And then, of course, to be more accurate, we can insert the word trans. So trans means the bulkier substituents are on opposite side of the alkene. So remember, on the skeletal structure, let's focus on this double bond right here. When you don't see any attachment here, it automatically means we have a hydrogen atom, right? To complete the octet rule. So this means that on this double bond, you have a hydrogen here and a hydrogen there. Okay? And what that means is this bulky component, which is an ethyl group, and then the other one is the methyl group, are opposite or on opposite sides across the double bond. And that's why we assign it as trans to pentene. So don't forget the dashes. Okay, let's have a more, I guess, complex structure. So how do we name this structure? So this is where we're going to have to assign or use the EZ designation, because remember whenever we have 3 or more non-hydrogen attachments, that's when we use the EZ designation. And again, if you don't see any attachment here, it means it has a hydrogen to complete the octet, okay? So how do we prioritize? It's simple. You basically just denote the molecular weight of each attachment on the double bond, okay? So the ethyl group here is 29 grams per mole, hydrogen is 1.08, chlorine is 35.45, and the propyl group is 43 grams per mole. So whenever we assign the E or Z, we basically look at the order of prioritization, which is just based on the molecular weight. The higher the molecular weight, the higher is the prioritization. So as you can see here on opposite sides, the propyl group, which is 43 grams per mole, and the second priority group, which is chlorine, are on opposite sides. So therefore, the correct designation for this particular compound is E for opposite, right? And the rest we can name normally, just like whenever you're naming an alkane. So again, the longest chain for this one is just across the structure. So that's going to be 1, 2, 3, 4, 5, 6, 7. So that's a heptane. If it's an alkane, again, it becomes heptene. And then you assign the number, the lowest number possible. So here, we will assign the double bond as carbon number 3, starting from this end. It's the closest carbon on the terminal side. Because here, if we count it from here, it becomes 4. Okay, so it's going to be then 1, 2, 3 heptene, right? But then you have a chlorine attachment here. So the chlorine attachment would be on carbon number 4. So that means the name for this structure would be E-4-chloro-3-heptene. So heptene is your parent chain, whereas chloro is your substituent. So again, this is very similar to the way you name alkanes. And again, this is why it's important that before you study the naming of alkenes, you know how to name alkanes. Okay, so just practice naming this. And for the cycloalkene version, it is going to be similar. So I'm not going to talk about that. All right, so that's it for nomenclature of alkenes. Let's proceed to properties of alkenes. So alkenes exhibit structural isomerism. So all alkenes with 4 or more carbons exhibit structural isomerism. So in other words, they will have the same formula, but they will have different connectivity. So sometimes your double bond could be on the terminal end or the terminal side. Sometimes it could be an internal alkene. And then it could also be a tertiary alkene. Another property of alkene is geometric isomerism. So I will share with you the structure, the 3-dimensional structure of alkene, but the double bond creates a restriction. So you cannot rotate this, the carbon double bond, into but2ene, for example. And so therefore, you are creating 2 isomers for this particular configuration. You have cis and trans, all right? And then, of course, we have this table with property versus characteristics. So physical state, similar to alkanes. If you have 2 to 4 carbons, they exist as gas. Around 5 to 16 carbons, alkenes are liquids. And then 17 carbons or more, they are waxy solids. Density is lighter than water. Solubility, it's insoluble in water, soluble in organic solvents. The boiling points, they are very similar to that of the alkane with the same number of carbons. And it increases with molecular mass because of increasing London forces of attraction. And then, of course, the polarity is generally nonpolar unless, of course, you have a polar substituent. It could exhibit some polarity on your structure. All right, so that's it for the properties. And let's go to the uses of alkenes, which I kind of alluded to earlier. So alkenes there are many uses of alkenes, and most of them are used as starting materials to manufacture products. So for example, it's used to manufacture plastics like polyethylene for making buckets, bowls, bags, and others. And then it can also be used for making ethane 1,2-diol, which is an anti-freezing agent for motor car radiators. And then it can also be used for the manufacture of ethanol and synthetic fiber. And it can also be used for the manufacture of polystyrene, used in making car battery cases and parts of the fridge. It can be used to manufacture plastic, polypropylene for making ropes and packaging material, and then manufacture of propanol used in making acetone. So you will find out that alkenes have a lot of reactions, and therefore they are very useful in manufacturing several products. Okay. So let's go to synthesis and reactions, which is a good chunk of this web lecture. Okay. So for the synthesis part, you will see that alkenes are formed from different functional groups. And if you desire to be a chemist, if you desire to be a chemistry major in the future, you will learn all the details of the, especially the reaction mechanisms of all these synthesis reaction. But for this morning, I am just going to share with you or enumerate these reactions just to give you an idea on how these alkenes are synthesized. So there are many ways to synthesize alkenes. You have industrial methods, elimination, synthesis from carbonyl compounds, synthesis from alkanes. You can form them from alkynes, and you can actually also form them from other alkenes by rearrangements and other related reactions. So again, I'm just going to enumerate these methods. So first one is industrial methods. So hydrocarbon cracking, which is very common in the petroleum industry. So alkane is subjected to heat in the presence of catalyst. And in this process, you form a mixture of alkane and alkenes and other products. And then, of course, you have the catalytic dehydrogenation of alkanes. So same thing, you subject it to high heat and then you use a catalyst. And as you can see, you form a mixture of alkenes. And then you also can synthesize alkenes using elimination reactions. So the first one is dehydrohalogenation. So from its name, you're basically removing a hydrohalide group from the structure, from an alkyl halide. And so in organic chemistry, I think we presented it in the alkane lecture already, but as you can see, the reagents are normally the solvents are or catalysts are in the bottom portion of the arrow, and then the other reactants are on top. And then if there's heat, we show the triangle there. It means heat, okay, or high temperature. So for dehydrohalogenation, it's in the presence of alcohol, that's your solvent, and heat, okay, and you also have alkoxide to form the alkene. Another example of elimination reaction that can form alkene is the dehydration of alcohol. So alcohol has the hydroxide group, and by eliminating that, you form an alkene. So we can also synthesize from other alkenes. So this is called olefin metathesis, where in the presence of catalyst, as you can see, you just substitute the attachments to each alkene. So kumbaga nagpapalitan lang sila. And then, of course, we have the hydrovinylation. And again, it's a reaction between two alkenes. So you can also synthesize it from alkynes, which has 3 bonds. And that one of the ways is through a hydrogenation reaction where you introduce hydrogen in the presence of what's called Lindlar's catalyst. And also you can form it with sodium metal, with liquid ammonia and butanol, okay? And then lastly, you have the rearrangements and related reactions. And you will understand why these bonds actually rearrange. Dr. Bunquin will talk about reaction mechanisms in a little bit, okay? So you have in reaction, Cope rearrangement, and Diels-Alder reactions. So again, if you're an aspiring chemistry major, you will learn this for, I think, there are 2 semesters of organic chemistry for chemistry majors, and then the I think it's organic, really instrumentation for organic chemistry is a 3rd course. Okay, so that's it for the synthesis. Before I proceed to the reactions, I just want to share briefly the structural features of alkenes in using the valence bond theory. And again, as like what I mentioned earlier, this is a prerequisite to understanding the 3-dimensional structure of alkene. So if you don't understand this part of this talk, so I encourage you to learn the valence bond theory, and there are several videos available that you can watch for simplified version. But by now, I'm assuming that you know the basics of valence bond theory. So carbon has the following valence orbitals. You have 2s, 1 2s, and then 3 2p. Okay, so these are the orbitals in an isolated carbon atom. But according to valence bond theory, they form what's called hybrid orbitals whenever they form a bond in an alkene functional group. So what happens is the 2p orbitals mix with the 2s orbital, forming 3 sp2 hybrid orbitals. And what's left is a 2p orbital on its own. It retains its original configuration, okay? So these are the carbon orbitals in ethylene. And just visualizing that, and by the way, orbitals are just the probability of finding the electron in space. So in other words, most likely, dito nyo po mahahagilap yung electrons. And we know that we draw the molecular structures in a 2-dimensional way for easier visualization, but in reality, you cannot really pinpoint where the electrons are. You can only know the probability of these electrons in space. So this is just to show you the 3D visualization of the hybrid orbitals. So again, as I mentioned earlier, for the hybridization, or for the carbon associated with the double bonds, so 1s mixed with px or py, and these are just arbitrary designation. So what happens is this sphere mixes with the double-shaped orbitals to form this mushroom-like hybrid orbitals. And then when you put them together, the structure becomes a trigonal planar arrangement with 120 degrees separation from each orbital, okay? So according to valence bond theory, that's the orbital responsible for the formation of what's called the sigma bond, okay? And therefore, remember you have this 2p that is unhybridized. That's what's left on the perpendicular to the sp2 orbital plane, okay? So this means that for example, this ethylene, the sp2 hybrid orbital, as I mentioned, are responsible for the formation of what's called sigma bond, which is end-on overlap of the orbital. And then the p orbital that is not hybridized is what forms the pi bond. So pi bond is designated two-dimensionally as the other bond on the double bond. Okay, so these pi bond is electron rich. As you can imagine, you have electrons just localized in this area, and therefore, if they're electron rich, they like what's called electrophiles. So makikita niyo po yan sa reaction mechanisms later. This is just a segue to that. Okay, and lastly, the pi bond causes the restriction of rotation around this double bond. Kasi nandyan sila. But generally speaking, these pi electrons are weaker. Okay, the pi bond is weaker than the sigma bond. All right. So this is the reason why alkenes are more reactive than alkanes, because of these pi electrons. So pag samasamahin natin lahat, sp2 orbitals would be on the plane, and then the p unhybridized 2p orbital will be perpendicular to the plane. All right. So as you can see, here is an overview of the reaction of alkenes, and this is not an exhaustive list. Marami pa po, and there are more reactions to be discovered. These are just the basic ones. So like what I mentioned, Dr. Jeff Bunquin will talk about the details, some of the details of reaction mechanisms, and I will mainly be enumerating the reaction. So here I have two major sections. You have our types. You have addition and oxidative cleavage. So for the addition reaction, you have electrophilic, catalytic, carbene, and then oxidative addition. Okay, so let's start with electrophilic reactions. So first, let's define nucleophile versus electrophile. So nucleophile means nucleus loving, typically negatively charged or have at least one electron pair. So they love, generally speaking, love more positive sites. Whereas electrophile, it means electron loving, typically either positively charged or have a partial positive charge. And this is because of the difference in electronegativity in the bond. Okay. So in addition reactions involving alkenes, this is the general equation. And so as you can see from the reactant side, you have the alkene reacting with another compound, and each component of this compound gets added to the double bond, right? X and Y. These are just generic names. There are no compounds or generic letters. There are no elements as X and Y. But so for addition reaction, we have what's called a reaction intermediate. So basically, this is what forms before the reaction or before the reactants become the products. And again, I can't emphasize enough that Dr. Jeff Bunquin will give you the basics of reaction mechanisms. So the reaction intermediate for addition reaction is what's called carbocation. So you have primary with 2 hydrogens attached to it, secondary carbocation with 1 hydrogen, and then tertiary carbocation with no hydrogen attached to it. So R means it's another carbon group attached to the carbon. So hydrohalogenation, from the name itself, is the addition of hydrogen and a halide group. So halide could be chlorine, bromine, or iodide. And so based on the general reaction, we have addition of H and X on across the double bond. So here we have what's called Markovnikov's rule, where it states that the the halogen will attach to the more substituted carbon. So take, for example, here on this side, we have two methyl groups. And whereas on this side, on the left side, you have hydrogen and carbon. So therefore, this side is more substituted, and halide will, or chloride will attach to that carbon. Similarly, for bromine, hydrogen bromide, that will happen. The bromide will be attached to the more substituted carbon. Another example of electrophilic addition is acid catalyzed hydration. So here you subject the alkene in excess solvent. This is just aqueous acid, nitric acid. And again, addition reaction, it follows the Markovnikov addition reaction, where the hydroxide gets attached to the more substituted carbon and hydrogen on the less substituted carbon. All right, so oxymercuration, demercuration, is also an electrophilic addition where the alkene becomes an alcohol. And again, it through the aid of mercuric acetate, and then followed by the mercuration by sodium borohydride in basic conditions. So again, this follows the Markovnikov rule, where the OH attached to the more substituted carbon. And then you have the hydroboration oxidation. So unlike the others, this one does not follow. This is an anti-Markovnikov reaction. And the best way to explain why is through reaction mechanism, but I'm not going to discuss that here. But yeah, hydroboration oxidation is an anti-Markovnikov addition. So as you can see here, hydroxide is attached to the less substituted carbon, whereas hydrogen gets attached to the more substituted carbon. All right, so that's it for electrophilic addition. Let's move on to catalytic hydrogenation. So in hydrogenation of alkenes, you add the hydrogen atoms on the double bond in the presence of catalyst. Okay, so these are just examples. Cyclohexene becomes cyclohexane, 1-octene becomes octane, and then styrene becomes ethylbenzene. And so the catalyst basically provides a way for this addition, and it's going to be organometallics, and I think it's Dr. Jeff Bunquin's expertise. But simply put, the catalyst provides the way to situate that hydrogen and provides a way for that addition reaction to happen on the double bond, on the side of the double bond. Moving on, we have carbene addition, what's called cyclopropanation. And generally speaking, you have a carbene forming a bridge across the double bond, or a cyclopropane. Cyclopropane has a 3-ring, and we know that this is highly unstable. So an example is a Simmons-Smith reaction, where you have diiodomethane, and the CH2 on the reagent gets added on the double bond, plus an enantiomer. And then moving on, let's talk about oxidative addition. So I guess in Gen Chem, we are familiar with the concept of oxidized and reduced. But in organic chemistry, when we say oxidized or reduced, it depends on a couple of things. So when we see that the number of hydrogen atoms bonded to a carbon increases, and or if the number of bonds to more electronegative atoms decreases, then we say that the carbon in question has been reduced. And the opposite is oxidation. So if the number of hydrogen atoms bonded to a carbon decreases, and or if the number of bonds to more electronegative atoms increases, then the carbon in question has been oxidized. And you will notice that in the next reactions that the products of these oxidative addition have less hydrogen atoms, and that's why they are called oxidative addition. So for this type of addition, we don't form a carbocation, but you actually form a three-membered ring reaction intermediate on the double bond. So an example is halogenation, where you add two atoms of halide, so or halogen. So for example, the halogenation of cis or trans 2-butene in a neutral solvent to form 2,3-dibromobutane. And then same thing for the halogenation of cyclohexene. 2 chlorine atoms get added to the double bond. All right. And again, as you can see, the number of hydrogens become less. So that means it's an oxidation reaction in organic chemistry terms. Halohydrine formation, so addition of halide and hydroxyl group. So X being chlorine, Br and bromide and iodine. So the names become chlorohydrine, bromohydrine, and iodohydrine. And here, as you can see, the hydroxide group gets attached to the more substituted carbon. The halogen gets attached to the less substituted carbon. And again, the explanation is based on the reaction mechanism of this particular reaction. Another oxidative addition is epoxidation using MCPBA, which is metachloroperoxybenzoic acid in the presence of dichloromethane. So as you can see, a cyclo or a three-membered ring is formed around or across the double bond. And then you also have hydroxylation. So there are two ways to form dihydroxyl-based compounds. So at first, I mentioned MCPBA. If you subject it in acidic conditions, it will open up and form what's called anti-dihydroxylation because you have two hydroxyl groups on the opposite side of the structure. Whereas if you use a permanganate in basic conditions, you will form the syn dihydroxylation, which you can see there are two hydroxide groups on the same side. So again, the best way to explain is by reaction mechanism. And finally, you have the oxidative cleavage. So you can use ozone to break the double bond here, forming an aldehyde, two aldehydes, depending on the substituents around the double bond. It can form an aldehyde, two aldehydes, or a combination of aldehyde and ketone. So for example, here we form a heptanol and formaldehyde. And then the third example, we form a ketone and an aldehyde. And then lastly, you have the oxidative cleavage via the potassium permanganate. So similarly, you form either, so you initially form, okay, there are two pathways here. So if it's a basic condition, then you form diols. Whereas if it's an acidic condition, you form two ketone groups, okay? And again, I'm saving the electron pushing for reaction mechanism. I'm just here to enumerate it. So I think this is my last slide. So just an example, more example of oxidative cleavage via potassium permanganate. So as you can see here, potassium permanganate can open up the ring, forming dicarboxylic acid. And then if you have a substituent on the ring, you form a carboxylic acid functional group and a ketone group. So that's really what I wanted to share with you guys. And Dr. Jeff Bunquin will talk about the overview of reaction mechanism that will help you understand why alkenes and organic compounds in general form products as they do. So, Dr. Jeff, I am turning the virtual floor over to you.
All right. Thank you so much, Dr. Dindi. Can you guys hear me? Can you hear me?
Yep.
Okay, and is my mic loud enough?
Yes.
Okay. Okay, let me switch things over to my slide. Okay, magandang gabi po sa inyong lahat. Let me just like do a couple of screen manipulation out here. And JP, are you seeing like the exact slide?
Yes, Doc Jeff. But should we share the raffle details for now, or?
Oh, sure. We can actually do that.
Yeah.
Share away.
I could probably. Marty, are you there?
Yes, Kuya. Ano?
Ayan, can you explain the mechanics of our...
Alright, so for the raffle po, magpo-post po si Kuya JP ngayon ng Google Forms. Kuya, siguro po pwede mo nang i-post yung Google Forms. Sa YouTube comment section natin, tsaka po sa Zoom chat box. And then after, paki-fill out na lang po yung Google Form. Ang hinihingi lang po namin doon is your full name and your email address. Tapos at the end of the Q&A part, we will be drawing 3 names essentially. So, dalawa po ang mananalo ng Organic Chemistry Model Kit and isang mananalo nitong John McMurray 9th edition Organic Chemistry na book at the end of the Q&A session. So, fill out the Google form lang po na i-post ni Kuya JP sa Zoom chat box and also sa YouTube comment section.
I'll share it later kasi I'm sharing it. So,
okay po. So later po habang nagtotalk si Kuya Jeff, ipopost po namin yung link for the Google Forms. So yun lang po. I hope manalo po kayo and join the raffle kasi free lang po ito. Thank you po.
All right.
Back to me. Okay. JP, please confirm. If you can actually see the right screen. Okay.
Yes.
Okay, so magandang umaga po sa inyo sa Pilipinas. Muli ako po si Jeffrey Bunquin. This time around, I will be sharing with you. It's a pleasure for me to introduce you to the world of organic reaction mechanism. So, una-una po, thank you so much to Dr. Dindi for actually giving us a fairly broad overview of alkenes. So from yung real-life application of alkenes, nomenclature, structures, synthesis of alkenes, how these chemical species are actually produced industrially, application. So gaya na nga po na sinabi ni Dr. Dindi, you will see alkenes present in a bunch of things that we use on a daily basis. And then she also went over the different classes of reactions that alkenes undergo. And so kung napansin po ninyo, napakarami. There's actually a plethora of organic transformations that alkenes undergo because, like the presence of the double-double bond, of the carbon-carbon double bond there is making these molecules reactive. So ang dami po nilang pwedeng i-undergo na chemical transformations and ang daming iba't ibang klaseng products na pwedeng ma-form. And so this time around po, so if you could just like imagine, ang dami po ng reactions, my intention for today is actually not cover all of the mechanisms po nun kasi buong textbook yun, aabutin po tayo siguro ng mga ilang buwan bago po natin ma-cover yan. But then, my main objective for today is, as the title of my part of this seminar suggests, is that I will introduce you to organic reaction mechanism. So essentially po, ang ginagawa naman natin palagi is we're trying to deliver the concepts in the simplest way possible na ma-appreciate po ng ating mga estudyante at guro sa high school level. And then again, at the same time, this could serve as a refresher course to college students or college educators who might need to actually brush up on their organic reaction mechanism skills. So yun po. Okay, so moving forward, so what should you expect from this discussion? So, okay, there are several parts to this talk of mine. So I'll start with the definition of organic reaction mechanisms, and then after that, gaya ng ginawa ni Professor Dindi, I'll also talk about some prerequisites. So ano ba yung mga kailangan yung malaman para magkaroon kayo ng medyo malalim na appreciation of organic reaction mechanism. So essentially, paano ba yung hindi nyo siya kailangang i-memorize? Yung isang tingin nyo pa lang sa molecule, alam nyo na kung anong parts ng molecules yung mag-react, which atoms will actually form a bond, which connectivities are to be broken when these chemical species undergo a chemical reaction. Fundamentally speaking, yung third item po na aking i-discuss for today will be the formation and breaking of chemical bonds. So yun po yung isa sa mga pinakamahalagang aspects of organic reaction mechanism, and I will show you why that is very important. The fourth part is the art of arrow pushing in reaction mechanism. Lalo na po sa organic chemistry. We typically represent the steps involved in a chemical reaction by using arrows. So yun po, ituturo ko yan sa inyo, the basics. And then, we'll be showing you some examples po. So for this particular lecture, I'm actually focusing on polar additions across a carbon-carbon double bond. So yung unang type ng chemical reaction that Dr. Dindi mentioned earlier. So for example, if you're adding an acid across an alkene, ang tawag din po dyan industrially, bukod sa alkene, those are called like olefins. So yun po yung mga example na gagamitin ko sa inyo. I will try to demonstrate things using yung ating slides, but then again at the same time, while Dindi was going over her talk, I also prepared models po para sa inyo, para ma-demonstrate natin kung paano ba talaga yung transformation. So magpapaka-vlogger ako, magkaganyan-ganyan ako mamaya. So anyways, all right, so let's start with a definition of reaction mechanism. So how is reaction mechanism defined? So a reaction mechanism is a formalized description of how a reaction takes place. So essentially, it talks about how we get from reactants to products. So ano ba yung pinagdadaanan? Ano ba yung mga steps that chemical species undergo during a reaction for them to form the final product? And when it comes to organic chemistry, the focus is actually on the connectivity of the atom. So with that, ang ibig sabihin po natin dyan ay structures. So we're dealing with structures. And then secondly, and I think like when it comes to organic chemistry, we actually draw a mechanism and represent the movement of electrons using arrows. So movement of electrons. Bakit ba tayo mag-focus sa electrons? Ano ba ang fundamental component of matter that's involved in bonding? So di ba po electron? So yan ang ating focus ngayon, more particularly valence electron. So dun sa mga estudyante natin, ngayon alam niyo na kung ano yung unang nating prerequisite. It's actually an understanding of electrons and how they are actually used to form bonds, and and how they are actually crucial in the connectivity of the atoms in a particular structure. Okay, so sabi ko nga, all of our examples are actually going to be, all of the discussions for today will be predicated around this type of reaction. So it's a polar reaction of an alkene. So essentially, you are adding hydrobromic acid to ethylene, or to ethene, to form a product that is called bromoethane. So JP, can you guys see my cursor? And I'm using the pointer.
Yep.
Okay. Opo, so ito, what's happening is this is ethene, this is a C2 alkene. So essentially, since dalawa lang yung carbon niya, nandun yung carbon-carbon double bond. It reacts with hydrobromic acid, And in the process, it actually forms bromoethane. So, okay, hindi ko muna i-discuss paano ba yung pagdraw ng mechanisms. But this is typically how a trained chemist will talk about this reaction, this chemical, this organic transformation in the language of reaction mechanism. So ako po, I will talk in my language. So for example, okay, so in this particular reaction, this is how it starts. The pi bond of your ethylene will nucleophilically attack the proton or the hydrogen in hydrobromic acid. And in the process, the bond between hydrogen and bromine will actually break. So mapuputol yan. And then what happens after that is once the hydrobromic acid bond is actually broken, you will actually end up having that hydrogen forming a bond with carbon. And then, yung isa naman pong carbon, doon sa ating carbon-carbon double bond sa reactant, it forms a carbocation. And that carbocation is actually electron deficient. So it will find a way to complete its octet. And so what happens is, since the first step liberates a free bromide ion, that bromide ion will actually attack that electrophilic center, and then ultimately forming your product, which is bromoethane. So ganun po ang lengguwahe doon, no? Ang dami yung narinig na mga technical terms. O baka po ba naguluhan na kayo, ano ba yung mga pinagsasasabi ni Sir Jeff? So yan po yung gusto kong ituro sa inyo. So kapag po kasi nagbasa kayo ng libro, lalo pa ng mga textbooks na that's written in a different language, medyo ang hirap po kasi talaga nitong i-digest kasi there's a lot of technicalities around this topic. So when you talk about organic reaction mechanisms, kailangan nyo gamitin essentially yung vernacular na kaparehas ng ginamit ko. Paano po kung nagsisimula pa lang kayo? Paano nyo ba talaga ito i-approach? So, dito na po papasok yung mga prerequisites na binabanggit ko sa inyo. So, sabi, gaya na pinakita kanina ni Professor Dindi, there's a number of things that you actually need to learn or to at least have some fairly decent understanding of for you to understand, like the topics that she mentioned earlier. But then this time around, like when it comes to organic reaction mechanisms, dalawa po yung most essential. The first of which is an appreciation of organic structures or chemical structures in general. So when we say structures, we're talking about Lewis structures and Lewis symbols. So dapat po, marunong kayo magsulat ng tamang Lewis structures and Lewis symbols kasi pag mali po ang inyong isinusulat or dinadraw na Lewis structure representation ng inyong compound, and then automatically po mali na ang inyong reaction mechanism. Secondly is a very strong grasp of octet rule. So since we're dealing with organic chemistry and we're actually dealing with atoms or elements that typically require an octet. So you have carbon, nitrogen, oxygen, and then your halogens. So typically, okay lang na ba sa malakas or malalim yung pagkakaintindi nyo ng octet rule? That is very important. Kasi sabi nga kanina sa definition, kailangan ang ating understanding ng movement ng electrons, as they are used to form or break bonds, dapat yun po ay solid. Ang pangalawa is bond polarity. So again, yung polarity naman, doon nyo rin siya kukunin sa appreciation of Lewis structures, but then you're just combining it with the concept of electronegativity. So when is a compound polar or not? Kasi yung polarity po na yan, that will actually dictate the types of reactions or the reaction mechanism that those chemical species will undergo during a reaction. So yan po. So ito po, I would like to highlight at the high school level ang ating pong mga guro. Kapag po naturuan nyo ng maayos sa Lewis structures, octet rules, bond polarity, dipole moments, electronegativity ang ating mga estudyante, you're actually preparing them well for a college level learning of organic chemistry, more particularly reaction mechanism. So yun po. So ito po, gusto ko lang din pong banggitin sa inyo that we actually have, I think this is a 2.5 hour lecture on how, or web tutorial on how to actually draw Lewis structure. So like in this particular lecture, we talked about Lewis symbols for organic and inorganic compounds. We talked about covalent bonding, polarity, formal charges and even exceptions to the octet rule. So kung ang mga estudyante po natin at ating mga guro ay kailangan ng refresher or kung gusto po ninyo ng Tagalog-English discussion of that na in a way that's simplified, ito po, we recommend that you watch this. This is actually uploaded on our YouTube channel. So, okay. So, before natin i-discuss, before natin himay-himayin yung unang example na pinakita ko sa inyo, so the reaction between ethylene or ethene and hydrobromic acid, before ko yun i-demonstrate sa inyo later, gusto ko munang i-introduce kayo to the concept of bond formation and bond cleavage or breaking. So cleavage means binibreak ninyo, pinaghihiwalay ninyo, or hinahati ninyo yung bond, because these are the elementary steps involved in chemical transformation. So kailangan naiintindihan po natin kailan ba nagpo-form ng bond ang dalawang atom. Kailan ba nagbe-break yung bond sa dalawang atom. And ito, i-present ko po sa inyo ito sa pinaka-relatable na lengguwahe. We'll actually come up with a lot of real-life analogies for this. Okay. But before we actually deal with bond breaking and bond formation, kailangan naiintindihan muna natin what is a bond. So in organic chemistry po, more particularly, the focus is a covalent bond. So a covalent bond is a bond that forms between two atoms that are sharing a pair of electrons. So dito po, sa ating drawing dito, there's a covalent bond between fragments or atoms A and B. And so this is what we call, or this is what Professor Dindi Yu Voils alluded to earlier as your sigma bond. So yung single bond na yan, we call that a sigma bond. And that sigma bond is also a covalent bond, and that is comprised of a pair of electrons. So one pair of electrons being shared by elements or by atoms A and B. So again, kailangan po basics of ano ba yung definition ng bond, dapat naiintindihan ng ating mga estudyante yan. And then Professor Dindi earlier as well mentioned about pi bonding. So this can become a double bond. So when we say double bond, the first bond is a sigma bond, the second bond is a pi bond. So pinakita po niya yung kanina. And then I'll talk about that again like later on, like in the example. Okay, so ang sabi natin kanina, we'll talk about the fundamentals of bond formation and bond breaking or cleavage. So ang una muna po natin i-cover is bond formation. So paano ba nagpo-form ang bond between two atoms? So there are two different ways by which a covalent bond can form. So the first of which is what we call a homogenic mechanism. So in the homogenic mechanism of covalent bond formation, what happens is that each of the atoms participating in the covalent bond will actually contribute one electron. So ito po yun. So atom A has an unpaired electron, and then atom B has an unpaired electron. So kumbaga po sa group project, kung ang binigay na assignment ng teacher ay, okay, student 1 and student 2, mag-form kayo ng bond. Gumawa kayo ng project together, ang expectation ng guru dyan ay equal participation. So ito pong homogenic, ganun po yun. So yung ambag ni B ay equal sa ambag ni A. Pag nag-form sila ng bond or kapag gumawa sila ng project, eh di ano yun, patas yung group work po, kasi parehas silang nag-contribute. So that is what we call a homogenic mechanism for the formation of a covalent bond. Okay, and typically, when it comes to organic reaction mechanism, so nakita niyo siguro sa example si Professor Dindi kanina, she was using arrows to demonstrate, the formation of bonds or the breaking of bonds. So when it comes to homogenic bond formation, i-represent natin yung flow, your movement ng electrons using a fishhook arrow. So isa lang, kung makikita nyo, yung hook niya is isa lang. So kapag nakita nyo po yan sa organic reaction mechanisms na nakadraw sa textbook, ibig sabihin yan, you're actually moving one electron or an unpaired electron. So in this case, there's a fishhook originating from B going into this region where A and B will form a bond. Ganon din po yun. Yung A, it has an unpaired electron. So therefore, yung fishhook rin will represent the movement of its electrons. So when those electrons, or essentially the orbitals where those electrons are present when they overlap, that results in the formation of a covalent bond. So again, tandaan nyo po yan, fishhook. That's how you represent single electrons moving during an organic reaction mechanism. So yan po yung papakatandaan po natin. And we call each of these species which has an unpaired electron, it's called a radical. So this is like a radical type mechanism for covalent bond formation. Okay. Next naman po. So kung kanina, homogenic mechanism, this time naman, we have this mechanism called heterogenic bond formation. So this time around naman, ito yung mas madalas siguro na-experience ng mga estudyante at mga guro sa klase. No? Kapag nag-assign ng project ang teacher, okay, go group into partners, student A and B, magagawa kayo ng project. Minsan, natsitsempohan, ang isang estudyante ay tamad, walang ambag. Yung isa naman, sobrang bibo or maraming resource, additional lang yung gagawa. But then at the same time, minsan yung mga estudyante naman na mga bibo, wala naman din po masyadong pakailam. So they're willing to share their electrons. So in a heterogenic mechanism for bond formation, the electron pair will only come from one source or from one atom or from one fragment. So this time around, B yung atin pong source ng electron pair. Tumatanggap lang si atom A, and that's how they form a bond. And whenever we and then this time around, since hindi po equal yung kanilang yung kanilang pag-share ng electron, kasi yun ang gagaling lang kay bilat ng electrons, si A tumatanggap lang siya. So we actually have terms for these species. So nabanggit rin na Professor Dindi kanina, yung ating mga chemical species, whether it be an atom or a fragment, that is electron rich and that is acting as the donor of electron, we actually call that a nucleophile. So when we say nucleophile, it is looking for a nucleus with which it will share its electrons. Pagdating naman po dun sa element A, it is electron poor. So it prefers to accept electrons. And so since it's an electron acceptor, we call it an electrophile. So kapag po meron kayong ganong estudyante sa klase, yung isa hindi gumagawa ng kanyang ambag at yung isa naman po ay overperforming, at yun po, pwede nyo tawagin nucleophile yung isa po electrophile. So ganyan niyo po i-brand ng inyong mga estudyante. No? So, and then we typically represent the movement of electrons during the heterogenic mechanism for bond formation in this manner. So yung pong ating regular arrow, yung double hooked arrow, so since dalawa na yung hook niya, that represents a pair of electron moving. So this time around, yung pong ating electrons is a pair of electrons is originating from B and is being shared with atom or fragment A. So yan po yung heterogenic mechanism for bond formation. So kung mapapansin nyo, yung end result is just the same. So pero nagkaiba po yung mechanism by which electrons are actually shared to form a bond. Okay po ba? All right. So kung meron po tayong bond formation, sabi ko kanina, meron rin naman tayong bond breaking or bond cleavage. So, again, babalik tayo dun sa fundamental understanding natin that, a single bond between atoms A and B that is comprised of a pair of electrons. So, lagi pag nakita kayo ng isang guhit between two elements, that is actually corresponding to a pair of electrons or two electrons. So, kaparehas ng mechanism kanina, kung merong homogenic, meron namang homolytic. So this time around, what happens is that when you break the bond between atoms A and B, equal yung pag-split ng electron pair. So isang electron ends up with A, isang electron ends up with B. So kung ang analogy po dito, kung dalawa yung anak, kung kayo po ay magulang at meron kayong dalawang anak at nag-uwi kayo ng pagkain, dito na po papasok yung term na hating kapatid. So equal po yung pag-split ng electron pair between the two atoms or two elements. So ganun po siya. But then ang result po niyan, gaya na pagkakahat ng sinabi namin kanina, ay dalawang radicals. Kasi if you're gonna represent the splitting of the electron pair, in this particular example is such that you're gonna use two fish hooks originating from the bond, and then yung tip po nun, or yung hook is actually pointing to the receiving atom. So atom A and atom B. So forming two radicals. So yan po ang homolytic bond cleavage. Okay, ito naman pong heterolytic cleavage. So starting from a single bond between atoms A and B, what happens is that yun pong buong electron pair ay napupunta lang sa isang to only one of the two atoms participating in the covalent bonding. So dito na po papasok kung kumbaga kung may dalawa kayong anak, binigyan nyo ng pagkain, dito na po yung medyo may pagkaswapang yung isa, yung pagka-selfish, yung isa po naaagawan. So yun po yung mechanism of heterolytic bond breaking. So dito naman po, I would just like to point out a couple of things as well. So B gets the entire electron pair. And if you're going to represent the movement of electrons during the breaking of the bond between A and B, this is how you are actually writing this. So originating from the single bond, you're actually going to direct the arrowhead to B. So ang result po nito is yung A, wala siyang nakuhang electron from that bond, and then it entirely ended up doon sa B. So hindi ko po to nilagyan ng ng charges, no, kasi these are just like more generic representations. But then later on makikita na ninyo na since hindi po balanse yung pagka-split ng electrons between the two atoms, heterolytic bond cleavage usually results in the formation of it results in a formal charge or in the changes in the overall charge of these atoms. So as early as like in those demonstrations po, I have actually shown that arrows can be used to indicate or to demonstrate the movement of electrons during a chemical transformation. So yung sinabi ko nga po kanina, if the splitting of a bond or if the formation of a bond involves one electron, like from each participating atom, then we call that a radical process. So either you're starting with radicals to form the bond or you break the bond to form radicals. Yun po ang radical processes that we are actually talking about. So again, homolytic and homogenic bond formation and breaking are actually what we use as descriptors for those steps. And then, when it comes to kapag nakakita po kayo ng reaction mechanisms with the typical double hooked arrow, dun nyo po matatawag that these are actually polar processes where the electrons actually move in pair. So dalawang electrons po lagi yung nire-represent ng traditional arrows. So again, heterolytic bond breaking and then heterogenic bond formation. So yun po. Keep that in mind, students and teachers. Malaki po ang pinagkaiba niyan kapag wag niyo po yung i-interchange kasi pag ipinakita niyo po yung reaction mechanism niyo sa mga chemists, iba po yung interpretation nila kasi these are conventions, these are actually standard ways by which we represent the movement of electrons during to represent a reaction mechanism. And then meron pa rin po yung mga certain intricacies that you have to watch out for. So the tail of each arrow should be pointed at the source of the electron. Ganun po yun. Kung saan po nanggagaling yung electron, dun po dapat nakapoint yung buntot ng inyong arrowhead. And then, the arrowhead, yun po mga hooks ninyo, these should actually point to the receiver or to the acceptor of the electron. So yung arrowhead, lagi yung nakapoint or nakaturo sa electrophile. Yung buntot po, laging nakaturo sa nucleophile. So, hindi po yan interchangeable. So, ito po yung mga usual rin na mga causes for mistakes po ng students whenever they write a reaction mechanism. So, minsan po, yung electron acceptor, parang sa kanya nanggagaling yung arrow. So, again, you're representing the movement of electron. So, kung saan nanggaling yung electron, nandun po dapat yung buntot. Kung sino yung tatanggap, dapat nandun yung arrowhead. Okay. So, simple lang naman po yung mga yan. But then again, like all of these basic ways by which we represent structures during reaction mechanisms and arrows and movements of electrons. Kapag pinagsama-sama niyo na po yan, baka malito po kayo. Kaya it's very important that you keep all these foundation knowledge with you whenever you are writing up an organic reaction mechanism. Okay, so mabalik tayo dun sa example. So, kanina pinakitaan ko kayo nitong given. So you have ethene plus hydrobromic acid, and then it reacted to form bromomethane. But then how can you actually come up, or how if we were to ask you to draw a probable and a reasonable reaction mechanism for this, how do you start? Paano niyo po ba yan naalamin? So dito, actually po, if yung prerequisites na binanggit ko sa inyo kanina, if you have an appreciation of the structure, of the right structures, of the octet rule, of bond polarity, of dipole moments, kahit po hindi nyo masyadong alam, or hindi nyo nabasa sa libro ano bang type na reaction yun, you'll be able to figure out a way by which you can draw a reasonable reaction mechanism. And yung first step po typically dyan is you have to analyze the structures of your reactant. So dito po, we have to analyze the structure of ethene, and then we also have to analyze the structure of hydrobromic acid. And this is how we are going to do this. So this is the structure of ethene. So sinabi nga po kanina na Professor Dindi, there's a carbon-carbon double bond present in there. And ito po, i-demo ko sa inyo. I need to be able to see myself as I do this. I'm just gonna move. Okay, my camera somewhere there. So ito po yung three-dimensional. It's a ball and stick representation of ethylene. So ito po, it's actually a planar molecule po where this is your carbon centers forming a carbon-carbon double bond. So yung una po ditong bond is the sigma bond, and then the other one is the pi bond. And then coplanar po with this bond are all the carbon-hydrogen bonds. And typically po, for most of the hydrocarbon transformations na tinuturo sa high school, no, these carbon-hydrogen bonds, unless in the presence of radicals, they don't usually react. Lalo-lalo na po sa alkenes. All of these vinylic carbon-hydrogen bonds are very strong bonds, so hindi po sila masyadong reactive. But then ang focus po natin ngayon is actually in this region. So this particular region has two bonds. So it has two pairs of electrons. So ilang electrons yun in total? It has 4 electrons around this region. So if you could imagine this po, itong gitna ng part na to, this is electron-rich. Marami siyang electrons. And then one very important thing is that the pi bond is actually is relatively more reactive than your typical sigma bond. So it's the presence of the pi bond that's making this fairly reactive. So gaya nga na po na sinabi ko dito kanina, in-indicate ko na ito, this is a region that is fairly rich when it comes to electron density. So dito po, since this region is electron rich, you can actually call this region or the pi bond a nucleophilic area. Okay, so it's a nucleophilic part of your ethylene or your ethene molecule. Okay, now, mapunta naman tayo dun sa hydrobromic acid. So sabi ko nga sa inyo kanina, if you have a very good understanding of Lewis structures and bond polarity, malalaman nyo, how would these behave during a reaction? So hydrobromic acid here, as I was telling you, is a polar, as I mentioned before, is a polar compound. So why is it polar? Because bromine is more electronegative than hydrogen. So when they form a bond, what happens is that an electronegative atom tends to withdraw or tends to attract more of the electron towards it. So kahit po itong hydrogen-bromine bond dito ay single bond, majority po ng electron cloud dito ay napupunta or lumalapit sa bromine. And that results in a net dipole moment, making it a polar compound. So sabi natin, more of the electrons are attracted towards, attracted towards bromine. So therefore, yung bromine dito is partially negative. Pag sinabing partially negative, mas mataas yung electron density around it. Pagdating naman po sa hydrogen or the proton in this structure, partially positive siya. So kasi naaagawan siya ng electron eh. Medyo may pagkaswapang po itong bromine. So in this case, partially positive yung hydrogen. And 'di ba sinabi kanina na Professor Dindi that, regions in a molecule that is partially positive, that is electron poor, and therefore you can call it an electrophilic center, an electrophile. Yung region naman that is electron rich, which is bromine in this case, is nucleophilic. So, and then yun naman pong pi bond or yung region dito that is very rich in electrons is also what we call a nucleophile. So kapag ganito na po yung inyong dissection ng structures of your reactant, malalaman nyo na alin ba dito yung posibleng mag-react. So therefore, dito kung iisipin nyo po, bromine, you can call it nucleophilic. Pero ang tanong po, between these two species, meron bang region dito sa ethylene na pwede siyang i-attack? Parang wala naman. Kasi diba sabi ko sa inyo, these carbon-hydrogen bonds are underactive. So therefore, walang region na pwedeng i-attack itong bromine dito sa inyong ethene. But then the other way around, your electron-rich area here in ethylene can attack the electrophilic center of hydrogen and hydrobromic acid. And that is actually how you map out the first step in a reaction mechanism. Ano ba yung mga parts? Ano ba yung moieties in your molecules na yung charges are yung nucleophilicity and electrophilicity are actually matching. So essentially po dito, yung konsepto lang ng opposite attracts. So dito, ang first step is that your pi bond or your electron-rich center between those two carbons and ethene will actually attack your electrophilic center. And why is that? It's because this is electron-rich, this is electron-poor. So partially positive, partially negative, opposites attract. So yan na nga po yung sinasabi natin. O, diba? Sa love life, yung good girls laging gusto ang bad boys. Parang ganon. Parang ganon yung gagawin yung analogy dyan. So what happens here is that, ito po, I'm gonna be using a model here. If this is the pi bond, what happens is that your ethene molecule will actually use it to abstract or to attack your, to abstract your electrophilic center here, which is your hydrogen. So parang yung pong first step po sa chemical reaction is such that your molecules should actually orient themselves in a way that's making that will make it possible for them to bond. So dapat po meron rin silang specific distance in space and orientation for the reaction to happen. So dapat po nagdidikit po yung mga yan. So kumbaga po sa bonding ng mga pagkakabarkada, mahirap po makipag-bonding kapag ang inyo pong kabarkada ay nasa malayo. So kailangan po didikit yan. So what happens is that yung initial orientations in space po niyan is that your proton should be close enough to your pi bond. And so what happens is ito po yung transition state na tinatawag natin. So dumidikit yung hydrobromic acid dun sa inyong ethylene molecule, and in the process your ethylene molecule is actually using its pi bond to attract or to abstract your hydrogen here. And then so what happens afterwards is that yung electron pair dito sa carbon-carbon double bond is being used to form a bond with hydrogen here. And in the process, kung mapapansin niyo po, nagfo-form ng bond between your alkene and your hydrogen with hydrobromic acid. And so ito po yung tinatawag natin na hypervalent proton or hydrogen. Sinabi natin hypervalent kasi it is actually getting surrounded, at least at this point, by number of electrons that's beyond what it can accommodate. Kasi ano nga po ang ating rule when it comes to yung bonding with hydrogen? A hydrogen atom only has a 1s orbital, and that 1s orbital can only accommodate 2 electrons. So kapag po dinonate or kapag in-attack ng inyong ethylene molecule yung inyong proton dito, therefore nagdo-donate pa siya ng electron pair. Meron na siyang electron pair dito, so magiging 4 na yung electrons around it. So that's what you call a hypervalent atom. And since lumalagpas na siya dun sa kanyang maximum number of electrons that it can accommodate, what happens is that kapag nag-form na siya ng bond with sana nakikisama yung model ko. Kapag nag-form na siya ng bond with your ethylene like this, what happens is that it also breaks the hydrogen breaks its bond with bromine. So ito na po yung mangyayari dyan. Yung next step dyan is that bond between hydrogen and bromine will actually break. So in the process, the electron pair that was initially used to form a covalent bond with hydrogen ends up being taken away by bromine. So ganyan po yung nangyayari dyan. So ito na yung resulting species nyo dyan. So yung hindi po stable ang hypervalent hydrogen, therefore it has to break a bond. It has to let go of something. So yun po. And so what you end up with is this structure. So you have your hydrogen atom from bromine attaching to one of the carbon atoms. And in the process, medyo nakakalungkot po para dun sa pangalawang carbon, kulang siya. So it only has 3 groups around it. So 3 bonds around it. So therefore, it only has 6 electrons around it. Ilan po ba ang kailangang electrons ng isang carbon atom for it to be stable? It has to have an 8 it has to have a total of 8 electrons. Kaya nga po, octet rule. And this particular electron deficient carbon species is what we call a carbocation. So it is a positively charged carbon center. So yun po, papakatandaan niyo po yan. Yun yung sinasabi ko kanina na when it comes to polar additions or when it comes to heterolytic bond cleavages, usually it results in the formation of species that are actually charged species. So positively charged carbon atom or carbon center and then a negatively charged bromine center. Okay, so ano po ba nangyayari dyan? So one very important thing that you have to keep in mind is that again, since the carbon, and I cannot emphasize this enough, since this carbon only has 6 electrons around it, it's unstable. So, kumbaga sa love life, ito po siya yung naiwan. Siya yung naiwan sa relationship. So, siya yung nakulangan sa sarili. So, and then ito naman pong si bromine, tinangay niya lahat. So, siya yung medyo may mga sobra naman siyang daladala. Okay. And so, as I've mentioned, carbocation, positively charged carbon, electron deficient, it is unstable. So, therefore, so sabi nga natin, unstable siya. Therefore, it's very active. Hindi siya kalmado. So, paano ba siya makakalma? So, it can only be stabilized if it will get what? An extra pair of electrons to complete its octet. So, what happens during this reaction is that since the bromide ion is just lingering around, what it's gonna do is that it's gonna use one of its electron pairs to attack this electrophilic carbon center. So, in the process po, kumbaga sa nag-break, nagbalikan din naman po yan. So, ang nangyari po, hindi pala nakipagbalikan, nag-form siya ng bond dun sa carbon atom. So iba na yung kapartner niya. Nakahanap na siya ng kapalit. So yun po, that's the process by which you actually stabilize that carbocation. You need a nucleophile to donate an extra pair of electrons to form your ultimate product, which is bromoethane. So yan po yung tinatawag natin na organic reaction mechanisms and then if you're actually gonna examine the net reaction po you started with ethene and hydrobromic acid. So what happens here for ethene during this reaction is that the pi bond was broken. The pi bond was broken because the electron pair and that pi bond was used to form a bond with your proton, and in the process your HBr bond is broken, and then ultimately the net effect is that you formed a carbon hydrogen bond and you also formed a carbon bromine bond. So that is what we call a polar addition across an alkene or a carbon-carbon double bond. Okay, so medyo madali lang po siya hindi niyo siya talaga kailangang memoryahan step by step ba niyan. Ganyan. Kailangan niyo lang na-appreciate, okay, octet rule, right structures, polarity, charges, yun po yung mga bagay na basic knowledge that you will learn from high school. So ito po yung sinasabi ko na kapag medyo hindi solid yung appreciation ng mga bata sa basic concepts na yun, pagdating nila ng college, hindi nila masyado itong ma-appreciate kasi hindi nila masyado nare-retain po yung foundation knowledge. So ganito ko po ito in-approach nung ako po yung nasa undergrad pa sa UP, and it actually worked. You'll be able to ace all of your exams when it comes to organic reaction mechanisms kung solid ang grasp of Lewis structures, polarity, and electronegativity. So mahalaga po yun. And ang maganda po kasi dito is that kahit po palakihin nyo yung alkyl chain, pag alam nyo po yung polar groups lang yung magre-react, hindi kayo malilito kasi alam nyo, ito lang yung reactive na part. Kasi yung iba naman, hindi naman sila nagpa-participate. Yun po yung importance of actually making sure that you have a very great understanding of all of these steps. Okay, and then yung i-introduce lang po namin sa inyo kanina is the concept of transition state, yung orientation in space ng ating mga chemical species for them to react. Kasi kailangan niya po yan, kailangan nagdidikit for your chemical bonds to form or to break. And then yung concept of an intermediate. So yung concept of an intermediate is actually when I showed you yung carbocation formation. And typically, these types of intermediates form whenever a particular reaction requires more than one step. So kung multiple steps po involved for you to get to the right structure or to the structure of your product, usually there is a chemical or a reactive intermediate involved. Okay, So, ito po, sabi nga kanina doon sa outline ko, practice makes perfect. So this time around naman, let's deal with or let's try to tackle these two examples. So, you have propylene reacting with hydrobromic acid to form 2-bromopropane. So ito po yung top example. And then yung pangalawa namang example po is that you actually have 3-methyl butene reacting with hydrobromic acid to form this species. So sige nga po, paano ba natin i-name to? So when we are naming alkyl halides, we actually we identify the longest chain, which is actually 1, 2, 3, 4. So this is actually gonna be 2-bromo, 2-methyl butane. So yun po. So yun yung product natin. So ang challenge sa inyo, kung meron po kayong pen and paper dyan, try to come up or to propose a reasonable and probable reaction mechanism for this. So I'll actually give you siguro a couple of minutes to copy these examples, and then after that po I will be showing you the answer kung paano ba natin nakuha tong reactions na to. So Marty, pwedeng orasan mo ng 2 minutes, and then after that siguro let's give them some time to answer to come up with an answer, and during that period baka JP, do we have some announcements that we can actually share in the meantime? Yun. So yun po, kopyahin niyo muna yung example na yan, and siguro we're gonna give you, siguro 5 minutes to try to answer to try to come up with a probable and a reasonable reaction mechanism for this. And then after that, ipapakita ko po sa inyo through slides and also using organic models. All right.
Should we make some announcement now, or?
Siguro JP, 1 minute for them to copy the structures, and then after that do the screen sharing.
Okay.
All right. Thank you. Okay, JP, siguro they can add. Let's just do the announcements habang nagsasagot sila.
All right.
Thank you.
Wait a sec. All right. So can you hear me?
Yes, Kuya.
Yeah. So as mentioned earlier po, we have the training course number 7 of the Fieldside Hub Research University next week. This is going to be about the best practices on writing a thesis, or the thesis writing process. And this will be delivered by Professor May Joan Aguila of the Institute of Chemistry, University of the Philippines, Los Baños, next week at 10 a.m. So yung registration po is on our Facebook page and also on our website. So kindly check that out. So next week, we're gonna start at 10 a.m. And ayun po, this is also gonna be Zoom and YouTube live event. So that's training course number 7 for the Fieldside Hub Research University. And malapit na po tayong matapos. So if you want to catch up on the courses, kindly check it out on our website. And for every course po, we are issuing a participation certificate. So even for the recorded lectures or the webinars, we issue a certificate of participation, and we're just counting on your honesty to really absorb and capture all of the lessons that we share there dun sa buong program na ito po. Okay? So that's gonna be next week again, June 12, Independence Day in the Philippines at 10 a.m. Okay? And after that, we have a special topic also under the Fieldside Hub Research University program. We have Green Chemistry, Principles and Initiatives, and this will be delivered by Professor Maria Catrina Vasquez de Paz of Adamson University. And that's going to be June 19, I think Dr. Jose Rizal's birthday, June 19, 10 a.m. Also here on Zoom and YouTube Live. And also the registration details are on our Facebook page and website. So kindly check it out and take part of this webinar about green chemistry and its principles and initiatives. So ayan, maraming salamat po. And I think, do I have the next slide? No.
Are we done, JP?
Yep.
All right. Okay, so we're resuming our discussion. So we're actually down to our 10 slides, and these are actually mostly a covering example. So yung first example po natin kanina is involving the reaction between propylene and hydrobromic acid. So yung standard mechanism that I actually showed earlier covers this. So this reaction will start with your pi bond in propylene attacking the electrophilic center, which is this hydrogen atom in hydrobromic acid. And in the process, since it's becoming a hypervalent hydrogen atom, it has to break its bond with bromine to generate what we call a carbocation. But then this time around po, kanina kasi it's very easy. When ethylene reacted, symmetrical po kasi yung the ethylene molecule is symmetrical. So therefore, whichever carbon you attach the hydrogen, wala pong diferensya. It will just give you the same carbocation. But then in the case of propylene, what happens is that there are two different positions on which you can attach your hydrogen atom or your proton. We typically call it as a proton po, and like for polar reaction. So it can either attach to the terminal carbon atom to form a secondary carbocation like this, or then this can actually attach itself to the middle carbon, generating a primary carbocation. So bakit ba natin tinatawag yan na primary, secondary, at saka po tertiary? So when we classify carbocations based on the number of carbon atoms that are actually attached to your carbocation center. So in this case, I cannot see my camera. Okay, I guess. Okay. So in this case po, you actually are you have the carbocation center, and then we classify it as a primary, secondary, or tertiary depende sa number ng carbon atoms attached to it. So in this particular example, this is your carbocation center, and it has 1, 2, 3 carbon centers surrounding it. So therefore, we classify this as a tertiary carbocation. And then if we remove one carbon and replace it with a hydrogen atom, so in this particular case, it'll look like this. So this carbocation center only has 1, 2 carbons atoms or carbon centers around it. So therefore, since it's only 2, then it's a secondary carbocation. Okay, now if you remove another carbon and you replace it with hydrogen, so this carbocation center only has 1 carbon center attached to it. So therefore, we call it a primary carbocation. So now when it comes to carbocation classifications po, the more carbon centers surrounding your carbocation center, the more stable it is. So yun po. So what I really would want to communicate here is that the most stable amongst the different types of carbocations that can be formed is what we call a tertiary carbocation, because it has 1, 2, 3 carbon centers around it. It's followed by a secondary carbocation which has 1 and 2 carbon centers around it. Of these 3, the least stable carbocation is a primary one because it only has 1 carbon atom around it. And bakit po ba ganun? So, ang sabi po natin, a carbocation center is an electron deficient center. So, kulang siya ng electron. So, what happens po is there's this phenomenon called hyperconjugation. So, hyperconjugation po, it's a way by which carbon centers can stabilize or can partially donate electrons through its sigma bond. So it's a fairly technical topic, and I will discuss it in a separate session. But then for now, we'll just accept that phenomenon occurs. Like if you have a carbon center attached to a carbocation, that can stabilize your electron deficient center. So kumbaga po, analogy nito in real life is that if you have a friend na nawalan or iniwanan ng kapartner, mas madali po kasing kalmahin ang tao na nawalan kapag mas marami siyang kasama, kapag napapaligiran siya ng kabarkada. So kapag tinanggal nyo yung support group ng inyong carbon center na yan or ng kaibigan nyo na nawalan or nasaktan, sino pong kakalma dyan? So it's becoming unstable. So yun po. So when it comes to reaction mechanisms, intermediates that are more stable, sila po yung mas favored na mag-form. So therefore, if your intermediate has a way to form the more stable carbocation, it will do that. So okay, so babalik tayo dito dyan sa example na yan. So what happens here is that your hydrogen attaches itself to the terminal carbon center for you to form the secondary carbocation, again, because a secondary carbocation is more stable than a primary one. And so since it's more stable, its formation is more favored. Yan po ang ifo-form ng nature. So ang nature po talaga ay meron sariling preference. And so since you form a secondary carbocation in this process, what happens is that your bromide ion will end up what? Attacking the electrophilic center that is this secondary carbocation. And so when it does that, the resulting product is this. So what happens is your proton attaches itself to the lesser substituted carbon. Your halide attaches itself to the more substituted carbon. Ito po yung tinawag kanina ni Professor Dindi na Markovnikov's rule. So when you're doing polar addition, say of hydrogen halide compounds across a carbon-carbon double bond, the bromide or the halide will attach itself to the most substituted carbon. So ito po, papakatandaan niyo po yan. Yung hydrogen, doon lagi siya pumupunta sa gilid according to Markovnikov. Doon siya sa less crowded na area. Doon yung gusto pumunta ng hydrogen. So ito po, students and teachers, don't forget about this because this is a very important rule when it comes to proposing reaction mechanisms or even predicting the products for reactions of alkenes. Okay, and so we're actually going to be making this more challenging. So this time around, we are actually using 3-methyl 1-butene reacting with hydrobromic acid. So sabi nga natin kanina, what happens here is that you start with the nucleophilic attack of your carbon-carbon pi bond at the hydrogen center in hydrobromic acid, and in the process, this hydrogen bromine bond will break to form, in this case, following the Markovnikov rule for the first step, a secondary carbocation. So yun po kasi yun. So you form a secondary carbocation. So, but the question is it happy enough? So sabi ko po kanina, if a particular intermediate or if a particular reaction or structure can form a more stable carbocation, it will it can rearrange. So there's this process called rearrangement that can happen. So ano po ba pag sinabi natin rearrangement, what typically happens is that, so this carbocation is surrounded by how many carbon atoms? So it's surrounded by this carbon atom and also surrounded by this carbon atom. So what happens is, if you would use this as a reference point as carbon number 1, then you have two different types of carbon number 2. So either this one or either the one on the left. And so what happens is that one of the groups in your C2 position can migrate to this carbon center to form the more stable carbocation. So for example, if we are to move or if we are to shift this hydrogen atom, kung ilalagay po natin siya dyan sa center, you'll be left with a primary carbocation kasi this carbon center is only attached to one carbon center. But then the other way around, if you would consider the second C2 position to the left of this carbon, say for example, if we move this hydrogen center over to the carbocation center, what actually happens is you will form a tertiary carbocation. So ito po yung process na mangyayari dyan. We call this a 1,2 hydride shift. So this carbon-hydrogen bond, so you move the hydrogen and this pair of electron with it, and you move it shifts to the carbocation center. So ano bang resulting structure dyan? Once you do the 1,2 hydride shift, what happens is that you form this tertiary carbocation. So bakit natin siya tinawag na tertiary? How many carbon atoms are attached to it? 1, 2, and 3. So if you're going to compare this with the original secondary carbocation, this is actually more stable. And this is actually what's happening in reality. So once you do this reaction, makikita nyo po is that hydrogen will transfer to the middle carbon of the secondary carbocation for you to form this tertiary carbocation. And it is actually this tertiary carbocation that the bromide ion will attack. So ito na po yung mangyayari. The nucleophilic attack of bromide will happen to the most stable carbocation. So yun po yung tinatawag natin na rearrangement when it comes to reaction mechanism. So these are things that you have to also know. So sinabi niya, kaya po pinapakilala namin sa inyo yung konsepto ng stability. So most stable is a tertiary carbocation. So therefore, nature or your active species will find a way, if possible, for it to form the more stable one. Kasi meron din naman pong mga rules that will not make it possible for things to actually shift. So, gaya nga po na sinabi ko kanina, hindi pwedeng yung hydrogen dito sa gilid ang mag-move dun sa gitna kasi it's forming a less stable intermediate. So you have to be mindful of these rules po when it comes to rearrangement. So hindi lang po siya proton, even alkyl groups, kahit po methyl group that can actually move to form the more stable carbocation. So ang suggestion ko po, if this is actually something that interests you, you check out, like textbooks po for more examples para mapakita to. And then what I actually plan to do is every once in a while po, I will schedule follow-up sessions po discussing reaction mechanisms for specific types of reactions. Kasi ito, isang type pa lang to na reaction, nakikita nyo, ang dami na ng mga possibilities. No? So, but what I promise you that we will do later on, ay hindi pa lang po ma-promise kung kailan yung mga follow-ups na yan, hihimayin po natin to this level. We will actually make sure that we actually can come up with analogies that everyone can relate to, and madali nyo pong marirecall. Ano nga yung sinabi ni Sir Jeff na parang analogy when it comes to our daily experiences, around people na marirelate natin sa reaction mechanisms. Okay, so ito yung homework na ibibigay ko sa inyo, no? And I highly encourage you to post your answers po dun sa ating Facebook page. Try to work on this reaction. Draw a probable or propose a probable reaction mechanism for this reaction. So this is a reaction between an alkene with hydrobromic acid forming the structure that's actually written, that's drawn below. So pakikopya na lang po, and then yun po, paki-post ng answers nyo doon sa ating Facebook page. Ipopost ko tong picture na to doon, and then baka pwede nyo sagutan sa comment section. And I would actually engage with you on that post. Ipapakita ko po sa inyo kung paano po ba ito ginagawa. And who knows, I might actually be able to shoot for a 2 to 3 minute video to actually explain how you end up with that particular structure of a product. So ito may mga alkyl shifts pa rin na nangyayari. So ito po yung challenge problem for that. Okay. All right, so I will be posting this on our Facebook page po. And then at this point, again, I would like to leave you with just these prerequisites po. So reaction mechanism, the types of reactions po that, we discussed like from the first part of the discussion. Technically po, if you have, again, a good appreciation of chemical structures, bond polarities, octet rules for formal charges, hindi niyo po kasi kailangan talaga hindi niyo po kailangan mag-memorize sa organic chemistry. Kailangan niyo lang pong i-leverage ito mga basic concepts na natututunan ninyo sa high school. If you take all these basic chemistry concepts to heart, kahit po anong iba tong complex structure sa inyo, alam nyo kung paano magre-react yung mga functional groups na yan. So, hindi po ito actually po, if you study organic chemistry by memorization, hindi po yan masyado magsistick sa inyo. But if you actually learn the art of drawing reaction mechanisms or imagining the transformation of those molecules in your head, yun po kasi that's what we call, like learning things by heart. So kahit po hindi nyo alam yung name ng reaction, ipakita lang sa inyo yung structure, alam niyo na kung anong gagawin dyan, alam niyo na yung first step. So that's actually how I would like to encourage you all to learn and practice writing organic reaction mechanism. So yun po, we would be happy to answer questions po, but then again at this point I would like to leave you like with these two main prerequisites for you to be able to perfect the art of reaction mechanisms and arrow pushing. Maraming salamat po.
Okay. Thank you, Kuya Jeff. And thank you for that talk. We will now proceed to the Q&A portion of this webinar. May isang tanong from, I think this is from Zoom, from Clinton Imbong. When can we use the anti and sign prefixes para sa naming ata to, Ma'am Dindi?
Okay, so yung sin and anti actually parang obsolete siya na ginagamit dati for naming. But the IUPAC rules just require the use of cis, trans, and the easy designation. So in our case, yung sin and anti, ginamit lang natin to describe the addition of those diols dun sa reaction kanina, but we don't normally use those for naming right now. Pero parang may makikita ko pa rin mga lumang articles or books using those naming system, but essentially they are the same as easy. So Z corresponds to sin and then anti is E. Pero yun nga, ang ginagamit natin ngayon is the easy or cis-trans designation.
Okay, so ayun, parang na-anuhan na rin tayo na hindi na siya masyado talagang ginagamit or obsolete na ngayon. So if you happen to encounter those terms, ibig sabihin po luma na yung libro na ginagamit nyo and you should probably upgrade to a newer version of that book. May questions pa ba tayo, Ja? Parang mayroon kang nakita, Ma'am Dindi, kanina sa YouTube, yung sa quaternary. Baka pwede nating i-enlighten yung audience natin about that.
Oh, okay. So, Dr. Jeff, may question tayo na kung posible daw bang mag-form ng quaternary carbocation. So, maybe you can you can answer that.
Oh, naku, handa ako dyan. Papakitaan ko kayo ng model, no? So, okay, please bear with me. Okay. So yung classification natin, di ba? Carbocation is actually a flat intermediate. So meron siyang tatlong bonds lang. So this is a tertiary carbocation, no? So it has 3 carbon centers around it. So take note of that. 3 carbon centers. So and then bakit ba natin siya sinabi na carbocation? Because it's lacking one more bond. So kasi 6 lang yung electrons around it. So if you attach another group to it, another carbon atom, then it's not a carbocation anymore because you have already satisfied its octet. So a quaternary carbon can never be a carbocation. Ayun. So yun po.
So, very clear. Very clear naman na hindi talaga tayo makakapag-form ng quaternary carbocation.
Okay, so yung trivia lang, no? So yung trivia lang, no? Sinabi ko kanina, okay, stable yung tertiary. Yung tertiary carbocation. Less stable yung secondary. Least stable yung primary carbocation. But then in reality, the most unstable carbocation is the one where you have no carbon centers around it at all. It's the carbocation that you can form from a methyl. It's a methyl carbocation where all of your surrounding carbon atoms, for example, all your surrounding atoms are actually hydrogen, for example. So that's an example of like even a lesser stable carbocation. So quaternary po, it's not possible to form a quaternary carbocation.
All right. So, yun, isa sigurong misconception na address natin for the alkanes and alkane group or hydrocarbons. May tanong po dito sa YouTube for Ma'am Dindi. In the nomenclature of alkene, which one should be adopted? The number before the name or the number within the name? Hindi ko po medyo magets yung...
They're both acceptable pero mas ginagamit yung number in between the name of the alkene.
Alright, so pareho siyang pwedeng gamitin pero ang preferred po Ma'am Dindi ay alin po?
Yung number ay naka-sandwich siya dun sa pangalan ng alkene. So for example, 2-pentene, normally makikita mo sa literature is pent-2-ene. Pero parehas naman silang acceptable.
Okay. So one thing I just want to mention, no? So we're giving away 2 sets of organic models like this. So yung mga bata at mga teachers po na nahihirapan talagang i-visualize yung structures, yung orientation and space ng mga groups, kung paano ba i-visualize yung reaction mechanism, magagamit niyo po yung mga ganitong klaseng model. Most chemists who are actually really good at organic chemistry, sila po yung kaya ng abstract thinking. So, or reasoning, so yung kaya nilang i-imagine yung molecule, patambling-tamblingin yan sa utak nila, and then i-map out yung mechanism. But then, hindi po kasi kailangan ganun kayo mag-isip. If you actually have tools like models like this, use them. Kung kailangan niyo po talagang isulat sa papel, isulat niyo po yan sa papel. So, those are like some of the tips that we can give you.
Ayan, so may nag-comment din sa YouTube, Kuya Jeff. Maybe you can also enlighten them. Bakit daw po yung nitrogen merong quaternary ammonium? Parang halimbawa po yung quaternary ammonium salts.
Yeah, it's because it's already a complex. It's forming a complex ion. So for example, so diyan na po papasok yung concept of formal charges. Yan po. So it's forming so a quaternary ammonium salt, a quaternary ammonium center, it still has an octet of electrons. So essentially pa actually pwede ko ipakita yan sa inyo. Sa model. So, yung lone pair po kasi ng nitrogen, it just shares its electron with an electrophilic center, for example, a proton. But then, so it's a cation, but it is actually not lacking an electron, like a pair of electrons. So that's the difference. It's not an intermediate. Hindi po kasi siya talaga a reactive intermediate. It is actually a stable molecule. Those quaternary ions, ammonium ions. So magkaiba po siya. We're talking about intermediates here. So complex ion formation na po yan. Yeah. You're talking about, coordination covalent bond. So doon na po pumapasok yung heterogenic bond formation.
Yes, tsaka strict follower yung nitrogen. So kaya niya talagang mag-form ng 4 bonds.
And yeah.
Ito po question again from YouTube. Bakit daw po tinatawag na unsaturated ang alkenes?
So unsaturated kasi po like based on convention, you call a molecule or a hydrocarbon saturated if all of the carbons satisfy their octets with single bond. So yun, lahat ng atoms surrounding each carbon atom is comprised of a sigma bond. Lahat yan, single bond. So kapag po yung tinatawag nating unsaturation is that once you remove a hydrogen molecule, yung pinakita nga ni Dr. Dindi kanina na dehydrogenation reaction, once you remove a hydrogen molecule from it, so okay, dehydrogenation, tatanggalan natin ng hydrogen molecule yung propane originally kanina, no? Tanggalan niyo ng hydrogen molecule, it will fly out through a catalytic process. Yung electron pair na naiwan nung inyong hydrogen molecule will form the pi bond. And that's what you call the unsaturation. If you want to saturate this, you have to break this bond and form two carbon-hydrogen bonds. Kapag meron po kayong multiple bond, that's what you call an unsaturation. Kapag wala na kayong multiple bonds, that's a saturated molecule already.
Also, usually associated siya with hydrogen addition. So kung may spot ka for adding more hydrogen sa structure like your alkenes and alkynes, then they are called unsaturated. Pero kung kompleto na yung octet with hydrogens, then we normally call them saturated.
Yep. And also, by the way, no, I would also just like want to clarify rin na yun nga, yung unsaturation is typically associated with multiple bonds as well. But then, meron din siyang mga gray areas like cycloalkanes and whatnot. Kasi if you calculate the degree meron po siyang formula, no, to calculate the degree of unsaturation for a particular molecule. So yun, baka pwede namin yung ituro later on. Let's say, for example, when we tackle alkyne. So idadagdag po namin yan sa inyo para mapakita namin sa inyo, okay, how do you really classify something as an unsaturated compound and a fully saturated compound. So, and it has real life applications po. Kasi if you work for example, the oil, the petrochemicals industry where you're dealing with all hydrocarbons and all of these hydrocarbon derivatives like alkenes, alkynes, whatever have you. These are things that these are nomenclatures that you use on a daily basis. So mahalaga pong naiintindihan nyo rin yan.
All right. So, may questions pa sa YouTube. Kuya Jeff, does the reaction mechanism also apply in the formation of polymers?
Ay, opo. Lahat ng, essentially lahat naman po kasi ng chemical transformations, for as long as you call it a reaction where it involves movement ng electrons, meron po yung reaction mechanism involved. But I also just want to clarify na, like for majority of, of chemical transformations known to mankind, karamihan naman po dyan, we have like some understanding of the mechanism. But then kung napansin niyo po yung sinabi ko kanina, we are only proposing, reasonable and probable reaction mechanisms. Means yung sa totoong buhay po kasi, all these arrow pushings that we're showing you, these are formalisms. So these are just like tools that experts like scientists and chemists like us are using to just like visualize things. Pero ang totoo po kasi if you're tackling reaction mechanism at the quantum level, medyo masisira na po yung textbook understanding natin ng mga bagay. But these are like very good guides and tools that we can use to teach fundamentals po or the basics. Pero lahat po yan, lahat ng chemical transfer reactions, may mechanism yan involved.
Yes, nagkakatalo lang sila kung alin yung mas plausible. Depende dun sa...
Yep. That's why kina-qualify po. Kaya ako kami po, if you talk to chemists, we're very careful about that. Hindi namin sasabihin na this is the mechanism for this. We qualify it all the time. This is a probable and a reasonable mechanism for this. So, hindi kapag po ang nakausap niyong chemist sinabi, ito yung mechanism yan, alam na alam ko yan. Medyo take things with a grain of salt. Yun po.
Iba kasi ang take ng organic chemist at ng mga physical chemist sa reaction mechanism.
Yep. So, ang totoo pong reaction mechanism ay ang atoms po natin, hindi po sila gumagamit ng arrows. So, pang sa atin lang po yan kasi ang brain capacity po natin ay hindi pa kayang i-tackle ang quantum level. So yung pong arrows na yan ay parang for dummies lang po for us. Pero sa totoong buhay po, like we're dealing with things at the quantum level. So yun po. Particle and wave duality, doon na yan papasok. But then, for the intensive purposes of educating our college and high school students and teachers at the same time, it's very important for us to have an appreciation of all these conventional ways of representing organic transformation mechanisms.
Tama ko dyan. Sabi nga ni Sinaida Seba, sila ay gabay lamang.
Opo. So pag po natutunan natin tong arrow pushing na to, no, wag po tayo maging masyadong self-righteous tas lalaitin natin yung iba kasi again, gabay, sabi nga ni Marty, gabay lamang po ito. So
meron kang quantum mechanics.
Yeah. And actually si Dr. Dindi, inuuno niya yung quantum nung nasa UP kami. So
Saka yung kasi di ba reaction mechanisms to prove that maraming experimentation kailangan to say that ito talaga yung pathway. So
and even in those studies you only get to establish certain steps.
Exactly.
You rarely establish all of the steps kasi for example, there are some reactive intermediates that you don't detect with experimentation. So there are those things that it makes sense, so therefore we can propose this. So this yung pong, again, we always qualify it, these are probable and reasonable reaction mechanisms, but I bet you more likely wala pa po talagang fully elucidized na reaction mechanism, with all the transition states and intermediates figured out with confidence. So yun po kasi yun. So ang totoo pong chemist na nakakaintindi ng mga gatong mechanism ay hindi po mayabang.
So I guess 1 to 2 more questions before we proceed with the raffle. Ito po nagtanong sa YouTube. When the halide bonds with the carbocation, can we call the bond a coordinate covalent bond?
No,
I don't think so.
No.
Kasi di ba Jeff, yung coordinate covalent bond is more on metal ligand bond.
Yeah.
So you can actually call that simply a covalent bond.
Yeah, a covalent bond. Yeah. It's a covalent bond. So medyo meron po siyang, there are certain qualifications kasi, pinupush niyo po yung mga terms na yan, no? But then, if you really want for us to have like a session on that, be prepared kasi we also have to deal with the concepts of Lewis acid and Lewis acidity and basicity, and even, like your concepts of different definitions of acidities po. I know that you mentioned quaternary ammonium salt, for example. But then you also have to balance it with like how with different chemical descriptors rin. Napapasok na po yung acidity. Hindi nyo po kasi pwedeng i-compare yung coordinate covalent bonds say with formation of covalent bonds among non-polar compounds. Essential non-polar compounds or your main group elements. So if it's a bond between carbon and halogens, typically, you just call it a plain covalent bond. Usually a covalent bond. Yan po. So, may mga gray, alam niyo naman po sa chemistry, ang dami niyang gray areas, but I actually like the fact na medyo, eto na naman, kasi kaya po ako nagpa-reaction mechanism, kasi noong unang lecture ni Dindi sa organic chemistry, meron po nagpo-push sa amin sa organic reaction mechanism. So, since na-challenge, masama po kasi akong hinahamon, pinagbibigyan ko po. So, nag-ano po ako ng reaction mechanism, mukhang hinahamon na naman po ninyo ako. Pagbibigyan ko po kayo dyan sa susunod.
Alright. So,
tingnan po natin kung sino po ang bibigay sa atin sa pagkalito. Ayun po.
Ito siguro last 2 questions na. Yung sa alkenes daw, Ma'am Dindi, kailan gagamitin ang cis-trans and kailan gagamitin ang easy?
Okay, so pag cis-trans, if you have 2 hydrogens sa structure mo, and then kapag tatlo na yung non-hydrogen, then we use the easy. You can go back to the video later. Actually, na-cover natin yan sa lecture kanina.
Okay. So, basta may at least, basta may dalawang hydrogen, cis-trans.
Cis-trans, oo.
More than 2 na ang iyong R group.
Oo.
Pag more than 2 na ang R group mo, easy
Kailangan na
lang
ng
yan.
easy. Mm-mm.
Alright. And then, lastly, Kuya Jeff, siguro, napasadahan mo na to kanina, pero bakit daw ang reaction is called 1,2 hydride shift?
Ay, kasi po from the first carbon, it's like the group is moving to the vicinal carbon. So yung neighboring carbon po, 1-2 lang yan, no? Yung mga shift po na yan, hindi po yan nag-1-3. Hindi po to double somersault. Isang somersault na po ang ginagawa ng ating mga groups na nag-move po dyan, whether it be a proto, a hydride, whether it be an alkyl shift, or whether it be a phenyl shift. Ano po yan, 1-2 lang po ang movement natin dito. Ano po? So, ang atin pong mga group, ano sabi mo?
Merong 1,4 ba?
Merong, nag-i-invoke ka ng mga mas complex na stuff. So, meron naman pong syempre merong mga exceptions to the rule, but when it comes to these things, ano na yun, mga super advanced na yan. So, but
conjugated yung
conjugated.
Pero for the intensive purposes of polar addition across what they call this, alkenes and the formation of their carbocations, yung na hydride at saka po alkyls lang yung nagsishift. 1-2 lang po yan. Wala pong 1-3, wala pong 1-4, at yung pag 1-1 po, hindi yung nag-move. So, watch out for that. So 1-2 lang po hinahinay muna po tayo. Lakad muna po tayo bago tayo tumakbo. Sa isang tumbling lang.
Alright. So basically, ang sinasabi ni Kuya Jeff is it's the position ng hydride from carbon 1 napunta siya sa carbon 2 based on sa
So essentially po kasi yung carbon 2 pala dito sa 1-2 shift na yan, yung carbon 2 yun yung carbocation. Yung carbon 1 doon nang gagaling yung group na lilipat para yung kumbaga ito po kumbaga since marami naman ay teacher siguro sa ating mga nasa audience dito, no. So yung isa po ay single, yung isa po ay may kaband. Since kulang po itong isa, humingi po siya ng parang inagaw niya po yung isa para maging stable siya. Ito naman yung nawalan. Pero kahit nawalan siya, yung resulting carbocation, medyo may pagka-stable pa rin naman siya kasi marami siyang kaibigan, marami siyang friends. To make that lacking center feel better. Parang ganun. Yan po, yan po yung mga analogy. So, feeling ko hindi nyo na makakalimutan yung mga carbocation na mga binanggit ko na yan. Tsaka yung mga homolytic, heterolytic. Kasi ginamitan ko na po ng konteksto ng relationships, friendship, group project, lahat na po. Swapang, hating kapatid. Yan po talaga yung pinag-isipan ko buong araw. Hindi na po itong mga chemical reaction to kasi 20 years ko na pong pinag-aaralan tong mga to. Kahit po siguro tulog, kaya ko pong ituro. Pero yung po mga analogy, talagang inilista ko po yan.
Yung 1-2 hydride shift daw, sumakabilang bahay.
Tama na po doon tayo doon sa hydride shift kasi baka maging mas skandaloso na po itong ating discussion po. Kasi yung tawid-tawid na yan, hindi medyo subject to interpretation. Napaka-arbitrary po ng meaning yan. Doon na lang po tayo sa nagpahiram.
So thank you po sa ating mga speakers, Kuya Jeff and Ma'am Dindi. Ang certificate po ay ang certificate to, ang link to the certificates for participation ay nakapost na po sa YouTube comment section and sa Zoom comment section. But before we go to our raffle, let me present this certificate of appreciation to Prof. Dindi Voils for delivering the webinar Introduction to Alkenes and Reaction Mechanisms organized by the Filipino Science Hub via Zoom on this 5th day of June 2021, signed by Dr. Jeffrey Bunquin and Mr. JP Onle. Thank you, Ma'am Dindi. Balik ka ulit.
Thank you. Salamat.
Alright, so ito na po yung pinakahihintay nating part. Yung raffle po. So mag-share na ako ng screen. Ay, wait lang. Kita nyo na po yung screen ko?
Yep.
Kuya JP, pakikita ko kung sino man
naman yung ruleta na yan.
Ano yun, Marty?
Ang dami pong nag-participate. So nakikita niyo po sobrang liit na ng mga names kasi ang dami nag-participate. So ang first winner po natin ay makakatanggap ng isang organic chemistry model kit. So, paki-take note na lang po, Kuya JP. So, i-roll ko na po. Ayan, so ang winner po natin ay si Rina Angela Cruz. So kay Miss Rina, paki-contact na lang po kami either sa Facebook page po namin sa Filipino Science Hub or sa email po namin, fieldside@gmail.com.
So that's Rina Angela Cruz.
Okay, so i-remove ko na si Miss Rina, baka manalo ulit siya. Okay, so ang next po nating winner is again another organic chemistry model kit. Congratulations po kay Ma'am Rina. Diba? Bongga na ngayon yung ano natin, paroleta. Alright, so congratulations to Miss Divine Therese Abalos. Again, nanalo ka po ng isang organic chemistry kit. Model kit. So again, message lang po kami sa Facebook, Filipino Science Hub at Fieldside Hub.
Okay,
Alright.
Marty, before mo i-draw yung yung last So, kung napansin niyo po kanina, actually yung ating book, the McMurray 9th edition organic chemistry book is actually sponsored by Professor Dindi Yu. So, bigyan ko lang kayo ng backstory, no. Kung napansin niyo kanina, she was actually quite emotional dun sa pagkukwento na okay, kung sino man yung makakatanggap niyan, make sure that you actually make good use of it, and kung hindi mo nagagamitin, i-donate mo to somebody else. Mayroon po yung personal na hugot kasi kami po nila Dindi, nag-aaral kami sa UP, magaling po kami kasi kami sa mahihirap na pamilya, nag-take po kami ng organic chemistry courses namin sa UP na wala po kaming textbook. So talagang umasa lang po kami sa pakakinig sa loob ng lecture at yung essentially yung kung ano man yung nasa notes, yun na rin yung inaral para po makasurvive. So this time around na medyo nag-iba na po yung buhay namin, quite fortunately, nagbibigay na po kami ng textbook. So sana po alagaan ninyo yan kasi talaga pong yung McMurray is the Bible of organic chemistry in UPLB. And I would actually like to proudly claim that I think UPLB has like one of the strongest organic chemistry programs in the country. So produkto po kami ng organic chemistry, and ako po kaya po organometallic chemistry ang aking major. So pinagsamang organic chemistry at inorganic chemistry. So alagaan niyo po yung book na yan. Alright, Marty?
Tama. Actually, parang halos tayong apat. Pati si JP wala rin. Actually, nahihirap lang kami sa IC Live, tapos parang may maximum number of days mo lang siya pwedeng makuha. Parang 1 to 2 days.
Kasi mahal po yan. During our days, siguro mga 2,000-3,000. Ito pa yung matagal, almost 20 years ago, mahal po talaga yung mga textbook na yan. So, and then, yun nga, swerte nung makakakuha. Sana po, i-share nyo sa iba.
Yes. Or kung teacher kayo, kung meron kayong promising students, ibigay nyo lang po sa mga sa chemistry.
Opo.
Ayan. So, ito na po yung grand prize. Sayang, walang pa sounds. Next time, magpapa-sound effects na ako. Alright. So, ito na po, mananalo po ng McMurray Organic Chemistry Book 9th edition, sponsored by Professor Dindi Yu Voils.
Di po ba napagod sa kani-lecture, nag-donate pa siya.
I-roll mo na.
Puro babae yung nanalo ngayon. Si Miss Eden Biando Rafalio. Again, Miss Eden, you can message us on our Facebook page, Filipino Science Hub, or email us at fieldsidehub.com kung para po maklaim ang inyong prize. So we will be waiting for your emails. Again, to recap, Kuya JP, makikibanggit nga po yung mga pangalan ng mga nanalo.
Okay, yung first winner natin is si Miss Rina Angela Cruz. First winner of the model kit. The second one is Divine Therese Abalos. And our grand winner for the organic chemistry book by McMurray is Miss Eden Biando Rafalio.
Ano na makakabalato kay Miss Eden.
Congratulations, Kuya JP. Do you have any announcements to make?
I think that's about it. We posted the event page. The event for next week, which is the course number 7 of Fieldside Hub Research University, the thesis writing process, to be delivered by Professor May Joan Aguila.
Yeah, Professor Dindi, meron na nag-message sa akin personally. Arins naman daw. So isa-isahin namin yan. Alkynes, after nyan, Arins. So, sige na lahat na.
Lahat na ng hydrocarbon family.
Opo. So,
sige.
Ayun po.
Alright. So
maraming salamat.
Ayan. Any final messages from Doc Jeff and Ma'am Dindi?
Enjoy lang yung mga napanalunan nyo.
Opo. And then, yun, practice makes perfect, essentially. Ito, sa mga estudyante, I just want to share, organic chemistry was actually like my, I consider it my most favorite organic chemistry area during my undergrad. Hanggang pagtanda ko po at pag-PhD, kahit sa trabaho ko ngayon, I'm dealing with organic chemistry on a daily basis. But paano ko ba siya na-ace nung ako nasa UP? Hindi lang po siya sa textbook. Again, sabi ko nga, dapat kung basic kayo mag-isip, madali na maintindihan yung reaction mechanism, polarity, positive charge, attaching to negative charges. Common sense. Kailangan niyo po ng common sense yan. Huwag lang kayo mataranta kapag nakita niyo yung structure. And then at the same time, practice makes perfect. Kung wala po kayong textbook, pero may access naman kayo sa internet, ang ginagawa ko pong practice nung ako'y nag-aaral sa undergrad, huwag na lang natin banggitin ang year kasi magkakabukuhan ng edad. Nagsa-search po ako sa internet. Practice problem sa Harvard. Meron dyan. I-download nyo, sagutan nyo. Pag nasagutan nyo na yun, handa na kayo sa kahit na anong exam. So practice lang po yun ang practice. Kasi yung memoryahan, hindi po talaga yan gagana. So again, yung mga prerequisites na binigay namin ni Professor Dindi, just keep them in mind and take them to heart and practice. So sanayin ng sarili.
All right. So with that, we conclude this webinar. Maraming salamat po for staying with us. I hope na makakasama po namin kayo sa mga susunod pa naming webinars. So next week and next week, actually hanggang June 26 meron. Every Saturday po talaga ng June ay meron po kaming webinar.
Actually, Martin, hanggang August, puno na tayo hanggang lahat ng weekends po hanggang August. Yung training programs for teachers, special topics for students and teachers as well for Research University. We're having our graduation from Research University in August. Si Dr. JP, si VP JP has a very good program planned out for that. So watch out for further announcements. So essentially hanggang end of the year po mapupuno ang mga weekends niyo. So maraming salamat po ulit sa pagtutok. We always appreciate you, staying on 2-3 hours every weekend to be with us. So this kind of engagement that we get from you, keep us motivated. And marami po kami mga big programs. Yung binanggit nga ni Sir JP kanina, yung ating training program for teachers that's sponsored by Fieldside Hub and a very reputable university, most especially when it comes to education. We're actually almost we're about to finalize all of the agreements, and then yung CPD units po, attend those webinars, take the assessments that we will be rolling out, and then at the end of it is very likely that you will get CPD units kasi gusto po talaga namin kayong bigyan ng mga material, but then again at the same time incentivize this engagement that you are showing us. And gaya po ng nakagawian natin, libre po, hindi po kami nagpapabayad.
Yes, thank you so much, Kuya Jeff. So lahat yan ay nasa pipeline na, kumbaga it's all about the processing of the documents already, pero lahat po nakasubmit na. With that, thank you so much everybody. Have a nice lunch. Late lunch na po ulit tayo as usual. Lalo na po sa lagi namin kasama tuwing Saturday. And have a happy weekend everyone. Stay safe and healthy.
Maraming salamat po.